Well, I am showing 120, so I'm gonna start. The people come in late are gonna miss out. Okay, so thanks for coming to this. Modules and packages live and let die. I'm not really sure what this title is about. It just sort of sounded kind of ominous and sort of cool there. So basically, what this tutorial is about is the most misunderstood feature. At least when I prepare Python tutorials, I always sort of think like, what do I know the least about? And then I try to learn about it, and I sort of realize I don't know anything about the import statement. Like really, like underneath the covers. I mean, I don't have to. Do people feel like import is a little mysterious, or that there's a lot of magic kind of underlying that? So that's what this tutorial is about. We're going to talk about modules, packages. I'll get into that in a minute. It is geared at Python 3.4. Which probably nobody is using. I don't know. In fact, there actually are some parts of this tutorial that require Python 3.5, believe it or not. So I think some of the things are kind of looking down the road. I'll point them out as we get there. You don't need anything else installed. There are a few code samples for this, but this is sort of a weird tutorial, I realized, in prepping it. In talking about modules and packages, there's almost no code. Right, you just make like an empty Python file with like a print statement in it, and then you try like, well, let's try importing that, and let's try reloading that, and like, so there are some samples. You can try to follow along. There'll be some experiments that you can try out. I wouldn't say there's like heavy like code density in this. Now to start this off, I'm going to start with some medieval art. So this is a pretty well-known piece of medieval art done by this Hieronymus Bosch. That I encountered. I think I was doing a Google search for maybe like the 7th inner circle of hell or something like that, and then came up with this image. It's basically this Garden of Earthly Delights painting from like the 1500s, and I was looking at that and I was like, that's kind of like, I don't know, that's kind of like the Python module and package sort of area to me in some way. Okay, so over on the also he's Dutch, by the way. So I was thinking of the connection between Dutch and Guido and Python and so forth. So I got to thinking, I was like, okay, the Garden of Pythonic Delights, and over here on the left, basically in this painting, you have the creation. All is great. You have Python, the standard library, batteries included. Anti-gravity. I don't know whether Guido is the creator in that or not, maybe. And then in the middle, there's just all sorts of crazy stuff going on. Hard to decide what's going on in the middle. Maybe this is the Python package index where you have 57,000 packages. I don't think it's PyCon, given that everybody is like naked and riding around on animals and eating weird fruits and stuff. So there's like all sorts of crazy stuff going on in the middle there. And then over on the right, you basically have hell, where there's like ears being sliced off and people being impaled by musical instruments and all sorts of crazy things. I'm not even sure what that is. I mean, is it like package management or I don't know what's going on there. But thought it was kind of a fun painting, and we'll see some things through that as we go. And so, basically, some background on this tutorial. I've been using Python for a while, all the way back to 1.3. Using things like modules and packages is actually it's like one of these things that I sort of figured out early on within like the first week. It's like, yeah, you use import to load things and so forth, and I haven't really given it a lot of thought since then, to be honest. Like, I don't spend a lot of time thinking about like the import statement, but in teaching classes and stuff, I sort of realized that like import is actually a really common source of confusion with especially like new Python programmers. It's a source of confusion with like installing packages and just like what is going on there. And so a big part of this tutorial is actually just going to try to correct that a little bit. Like just like I'm going to go look at import because it's clear that I don't quite know what's going on. So we're gonna do kind of a fresh take on modules. I'm kind of thinking of it from the point of view of just kind of reintroducing the topic from scratch. Like if I had to take Python today and just reintroduce the module system, I'm gonna do that. Maybe avoiding some crazy hacks or doing new ones. We'll see as we go. The target audience for this, honestly, is myself. I find that understanding import has been useful in writing applications. I'm also in the process of doing a book update. I don't know if maybe kind of a shameless self-interest there in doing that, but I'm trying to figure out like just what's going on with import, and so forth. One thing that I will say about this talk, I am kind of looking at it from the point of view of an application developer. I mean, I'm working on some projects. I'm thinking about, is there knowledge that I can take away and use in an application? I'm not thinking about Python core developer. We're going to look at some low-level details, but this tutorial is not meant to like turn everybody into a core dev or something like that. So that's the target. Also, one thing about this, the title of this is not modules and packaging. So this is not going to be 3 hours about pip. I hope did anybody want to come to a 3-hour pip tutorial? I sort of realized in doing this that there's like limits to one's knowledge, and that I am not the one to talk about pip. Okay, I talk about modules and packages, but we're not going to get into some of the gory details of some of that stuff. The other disclaimer on this, in the process of preparing this, this is going to sound really bad. I was riding my bike on a frozen lake and fractured a rib. So this is my one opportunity in PyCon to actually claim that I prepared this tutorial on drugs. Okay, so if we get into the I was like on narcotics for like 2 weeks dealing with the pain of that. So if we get into the middle of this and I'm staring at the slide, wondering what the hell was I thinking doing this? It's my disclaimer there. So. All right, so the first part of this, one thing procedure too, jump in with questions at any time. I'll acknowledge you, try to repeat the question on the mic and so forth. Okay, so first thing we're going to do is we're going to do a little bit of review. This is stuff that I hope most Python programmers know about or coming here. So some basics. Any Python file that you make is a module. Make a file with some definitions in it. You use the import statement. It loads, you get the definitions. Hopefully people have made it that far. Another thing about modules, every single module is its own isolated world. So anything that is defined in a file is basically private to that file. You don't get collisions between names. Okay, so like the X in those two files, that's a different X. Namespaces, it's part of the Zen of Python. You need more namespaces. Global variables are basically bound in the same file. This is maybe a little bit weird, but if you define a function and you refer to a global, like that X, it's always the X that's in that file. Sometimes people get confused about that because they might do a statement like from spam import blah or something, and then they sort of wonder like, well, how does it find the X? It's always the X that's in that file. Basically, functions actually record they actually record what module they were created in, and they're sort of permanently bound to that. Okay, so you have that. Module execution is very much like a script. When you do the import statement, Python just loads the code and just runs it top to bottom. Everything that's in there will run. It's just basically just like a script. You will see these variations on the import statement, like from math import sine cosine. Essentially allows you to drop the module prefix, so you don't have to say math.sine, math.cosine. Really just kind of lets you use parts of it without that namespace. And then sometimes you'll see the from import star being used. That just brings everything in and makes it available. Apparently people, I don't know, like this spawns like zombies or kittens die or something like that if you do that. All I'm going to say about import star, I think it's sometimes useful, but don't go overboard with it. There are cases where that can be useful. One confusion on some of these import variations, the from form of import doesn't actually change the way that import works. There's actually a question I get asked a lot doing classes. Sometimes people see this statement like from math import cosine sine or something, and they think, oh, Python must be super smart. It will go out to that file, and it'll just lift those two functions out and bring them in, and then the rest of the file is like still on disk or something. Or they'll think that form of import is a more efficient way to just load selected pieces of things. That is actually not how Python handles that. I mean, behind the scenes, it brings the whole file in, and it's sitting in the background. So there's no efficiency win as far as like what gets loaded by doing that. So you sometimes get that. Module names, there are some restrictions there. Basically, you have to follow the rules. It has to be a valid Python variable name. So common problem is people using weird file names like, too bad, or using a hyphen in a file name or something won't import. Actually, if you want a really awesome adventure, by the way, is in Python 3, create a module that has a non-ASCII character on it. I was experimenting with that recently with sort of an April Fool's gag, and it creates like chaos on the file system depending on what operating system you're using. So don't use non-ASCII names. There are some conventions with namings. Basically use lowercase. Is kind of standard. Use an underscore if something is private. It's kind of the same as with classes and functions and other things. And then don't use names that match standard library modules. Just basically confuses people if you do that. A few other things with modules. Again, these are basics. There's this sys.path variable that you probably know about. If your file is not on the path, it's just not going to import. End of story. Occasionally, you might write code that kind of hacks that. I'm actually a little. I mean, how many people have written code where you hack sys.path? Yeah, okay. The rest of you are just lying, basically. So, yeah, I've done that for different things. Feels sort of wrong. And then some other odds and ends. There is a module cache behind the scenes when you do an import. Basically, that import only happens once over the lifetime of the program. This is actually something that bites a lot of newcomers to Python. Just as an example of that, I will do an example of that. So here's sort of a simple module, something I already prepared. Okay, so let's say you had that. I mentioned earlier that the code for this tutorial is like almost non-existent. It's just like stupid things like that. So if that was your module, a very common thing that somebody will do is they'll say, okay, I'll import spam, and then they try to do some function in there, and then they come back to the code and they make a modification to it. I don't know. We make like the awesome spam.grok, and then they come back here and they try to figure out how to reload that. One thing about reloading in Python 3, by the way, is it has been kind of hidden away in a less obvious place, but you can say, oh yeah, okay, reload the spam module, and then, oh actually, I'm totally doing this wrong. Okay, actually the confusion is that they do the import twice, basically. We'll talk about reloading in a second. Okay, so let's say you have that. And then they change the code. Okay, I guess I have to make this the more awesome spam.grok. They'll do a repeated import, and then it doesn't pick up the code. It doesn't pick up the change. Okay, so that's a very frequent thing that you see. Maybe debugging Python. I mean, I've made that mistake. Like late in the day or something. I'm like, God, why is it not using my modified code? The reason for that is that that Python does have this cache. Basically sys.spot modules. It's sort of keeping track of everything that's got loaded, and then if you do a repeated import, it just pulls it out of cache. Okay, very, very frequent sorts of problems there. You can reload modules. So I tried to do that a second ago. That is apparently like a really bad thing to do for reasons we'll get to later. So zombies get spawned in your program if you do that. Not a recommended thing to do. And then a few other just kind of odds and ends. If a program is going to run as a main program, you often see this check, sort of saying, if name is main, run kind of the main script. Basically, this underscore name is just the name of your module, and if you're the main program, it's set to _main there. You've probably seen that. Hopefully, you've seen that before. And then for kind of larger collections of code, pretty standard to organize it as a hierarchy. Make a directory structure, you put your files in there, and then you have to go through and add these init.py files. And then once you do that, you can do these nested imports. So you can say things like spam.foo or spam.bar, import grok, and so forth. So those are kind of basic things that I would claim I think most Python programmers know about. I mean, I would hope people here would sort of have seen most of that, like packages, reloading, modules, and so forth. So let me just pause. Everybody good with that? Questions about that? Any lingering questions about any basics there? All right. So the rest of this tutorial. Okay. So that's some basic stuff. Now you're saying, okay, what is the rest of the 2.5 hours of this thing? There's basically everything else that we're going to talk about next. Okay. So So this is going to progressively build up into sort of more maybe insane things as we go. So the first thing that we're going to talk about for real here is essentially how to work with Python packages. That basically that directory structure that you get. And just to set that up, you can pose some questions. You can say, well, okay, what is a better way to code? Would it be better just to make one Python file with like 10,000 lines of source code in it and just be done with it? You know, like the one file program. Most programmers would probably not like that. I mean, it's generally a good idea to break things up into multiple files. On the other hand, if you do that, where do you put all those files? I mean, you probably would not want to take like 20 files and just drop them at the top level in like a Python installation, because you're just going to annoy people. I mean, it's like, how do you pick the names of the files? You know, where do you put them? So putting things in a directory is definitely a better way to structure things. And that's really kind of the idea with packages, is you're taking your code, putting it in a directory. But then you get some of these other questions, though. You know, how do you handle the imports later? I mean, if you break your code up into like 50 files or something, do you make the user do like 35 imports at the top of their program, or do you have like tons of import statements? I'm actually not, like, personally a huge fan of having to remember tons of imports. I don't know how people feel about that, but I kind of get, like, personally I get kind of annoyed if I'm using some package and I have to put like 20 imports at the top of the program just because the thing is kind of split up. Again, maybe I'm in the minority on that, but I feel like the one import kind of fits my brain a little bit better. So one of the things that you're seeing here is that packages actually introduce a lot of complexity over modules. I mean, if you're working with a module, it's just one file and like everything is easy. But if you get into packages, all of a sudden you get into these issues about how do you organize code, how do you do connections between submodules. I mean, how does that work? So we're going to talk about a few details concerning this kind of connections between modules and things related to that. And the very first thing we're going to talk about is just how to do imports within the package itself. So one of the things that comes up is, you know, let's say you do split up your package into multiple files. How do you do like cross references between files? So let's say you had a package and you have two files in there, like foo.bar and foo.py and bar.py. Let's say the bar module wants to import the foo module. You know, like how do you go about doing that? It turns out that in Python 2, it's actually very sloppy about this. In Python 2, if you're in this file bar and you say import foo, it'll just work. It will find that file in the same directory. That has actually been disallowed in Python 3. You cannot do that anymore. So that's like if you try to do that import in Python 3, it's going to blow up saying I don't know what you're doing. If you want to fix that, there are a couple of alternatives. One of the things that you can do is do I guess like a fully qualified import, where you can say, okay, from spam import foo. That's one thing that you can do. So just as an example of that, I think I have a simple package here. Package. Basic package, yeah, basic package. I don't even know my own tutorial here. Okay, so let's say you had like this. Okay, so let's say the bar file here, wanted to import the foo file. I mean, you could do something like this. I mean, you could say from spam import foo, for instance, and then that will basically let that work. We'll try this. Okay, make import spam.bar, and both things import. The thing that I don't like about that absolute import, though, is I just don't like the hard coding of the package name in there. I mean, like for instance, if I were to change the name of the package, okay, I'm going to change this to, instead of spam, I'm going to call it spam2 or something. If I do that, I basically break the whole universe, because it doesn't know what spam is anymore. And there's actually, and you can say, well, I mean, okay, I'm not going to rename the package. I actually disagree. I think there's a lot of reasons to rename packages. Maybe you want to have different versions of the package on the machine. Maybe you want to move it around. Maybe you want to have a copy of it. There's all sorts of reasons why you might rename it. So I actually don't like that approach that much. I just feel like it makes the code fragile by doing that. So an alternative is to use this feature known as basically a package relative import. I think this is becoming more common, but this used to be kind of an exotic feature. You could say, okay, from dot import foo. That just tells Python that I'm going to load foo from the same directory that bar is in. And you don't encode the package name in doing that. This has actually been something. This is something that's been around for a while. I think it got added in Python 2.5. So I don't know when did 2.5 come out. It may be around 10 years already. So this is something that's been around. I actually really like it because it does avoid this problem of hard coding the package name. You can change the package name. You can move it around. You can do all sorts of things with it. The imports are basically going to work the same way that they always did. So if you need to do kind of cross references between modules, that's one way to do that. One thing that's a little bit unfortunate, and I'm going to get myself into trouble here, PEP8 is a little bit muddled on this topic of what you should do with package imports like that. Okay, so I don't know whether you can read this in the back. This is my personification of PEP8 here. Okay, so we have PEP8. Basically what it recommends is, at the top it just says absolute imports are recommended. I'm not going to read the rest of it, but they basically recommend the first approach. I'm actually going to disagree with that. There's a lot of violence in this talk, by the way. I apologize for that. Okay, so I just do not like the absolute imports. I mean, maybe there was a time where that was like a good idea, but it's I don't know. I just don't like them. The other thing that that PEP8 sort of says at the bottom down here is it sort of says standard library code should always use absolute imports. And that's totally wrong as well. The standard library is using relative imports already. Like the async IO library uses it. There's a lot of other places that are using relative imports. So the Python library is not even following its own rules on PEP8. And so I'm actually a big. I think you should use the explicit, like the relative imports. Basically, it's a great idea to do that. The library is doing that. I think modern code is doing that. So. Maybe don't have violence toward PEP8, perhaps, but it's that part of it is maybe a little bit out of date. I think the advice is a little sketchy. So definitely do the relative imports if you can do that, because they are used. I'm actually a little curious. I mean, how many people have seen like that relative import thing before? Are you using that? Do you like it? I think it's great. I mean, it maybe like the first time you see it is a little weird, but it's yeah.
Using those relative imports, does that create problems with the ability to pull a small piece of atomic functionality out of a package and reuse it elsewhere?
Yeah, the question is is using that, does it make it harder to pull something out and use it somewhere else? Are you thinking of just copying the source code to somewhere else? And
I would just assume that there's some module that is useful on its own, but it has a relative import in it once you sort of pull that out. Does that create problems? Maybe I'm just not getting it.
Yeah, no, I could see that. Yeah, I mean, if you had if there was some fragment of a package that you just wanted to copy literally out into some other place, yeah, I could see it screwing that up. Don't do that though. So, yeah, I don't know. It's like it kind of gets in this. I had somebody. Well, I'm not gonna name names, but he's like, yeah, I had monkey patch Django. I'm like, oh, really? Okay. And he sort of described what he did. He's like, yeah, I went into the actual site packages directory and just edited the code in place. Sort of like a horror of no, don't be doing that. So yeah, I don't know whether you want to copy code out or not, but yeah, potentially a problem. Yeah. And then some other things with packages. What are you supposed to do with the init.py files? Okay, so if you work with packages, you're supposed to put those init.py files in there. They can be totally empty, which is actually perplexes newcomers sometimes. They're like, what? I have to make an empty.init file? What's that about? And so what the init.py file? Well, there's a lot of things that you can do in there. But I think the main thing that you should be doing in there is maybe just stitching things together. This is actually a very common use of those. So one of the things that you can do with those inits is essentially take things that are spread across multiple files. Like you can say, okay, let's say you have two files, foo.py, bar.py. Maybe they have some class definitions in there, and you want to combine those together. One of the ways that you can do it is in an init file. You could say, okay, in init.py, I'm gonna hoist those symbols up And then what's going to happen is a user will just see kind of a unified module. They'll just say, okay, import spam. It will magically have foo and bar in there. And they don't actually have to know how that got structured underneath. I mean, it's, you know, it could be coming from multiple files, could be one file. It's just an implementation detail. So this is actually something that is done in the standard library. You know, like one of my favorite modules is the collections module. If you're not using collections, by the way, you should start using collections for stuff. Turns out that the collections module is not actually a module, it's actually a package. And it assembles things from a few different places. So there's actually an extension module with some C code in it. And then there's a file with some class definitions, and then you have things like order dict and counter. And so essentially the init file is sort of bringing all that stuff together into one place. Actually, one little, this is sort of a side trivia note on the collections module. Sometimes people look at that module and they're like, why are some of the things in there lowercase and some of the things uppercase? I don't know whether anybody's wondered that. Like, why is default dict and dec lowercase, and why are things like ordered dictionary and counter uppercase? Turns out that they're following PEP 8 on that. Turns out there's a convention for things implemented in C or things that are built in to be lowercase, like list, dict, tuple, set, string. So those are all lowercase names, essentially, for types. And since dec and default dict are implemented in C, they're lowercase. And then the other things are uppercase because they're classes written in Python. There's just a bit of trivia on that. If you ever looked at that module and wondered why is it so inconsistent or weirdly inconsistent like that, that's what's going on. All right. Now some other things that you can do. In combining modules. Turns out if you're going to do submodules, it's usually a good idea to define this all variable. This is actually a way of controlling exports from that star import. So what you can do is you can just list everything that's going to be exported, and then if somebody uses this from module import star, only those symbols are basically going to pop out. So you're having control over that. It turns out that this is actually a really useful thing in packages, because what you can do is use that to kind of easily combine things in those init files. What you can do is in an init, you can use these like from import star statement, which apparently you're never supposed to use, by the way. But it's actually very, very useful in init files. You basically just import everything there, and then what will happen is it will just kind of unify in that init file. A little bit of a picture of what's going on is really this. I mean, each submodule basically has its list of symbols, and then they just kind of collect together in that init file. Again, that's actually something that's used in the standard library as well. Asyncio does that. So it turns out that if you look at the implementation of asyncio, there's actually a whole collection of files that are defined for that. They all basically define exports with the all, and then the init file is just assembling the whole thing together into just a unified whole, essentially. So that's one thing that's kind of useful there. Let me just pause, see if everyone okay with the idea on that. You're exporting symbols and then bringing them towards the top. Yeah, question.
Just the asyncio example over the side there. You're importing all the stuff.
Yeah.
With the star, but later on you're using the underscore all to put it all back together. Could you just import the packages and then say .all underneath, or do you actually have to import them with the stars?
Yeah. So the question is if I understand it right, is about this. Like I did a from.futures import star.
That kind of does it already.
Yeah, but then here I'm actually using like the fully qualified name. Isn't that a little weird? That's just not the way that the import star works. Normal, like I think that's what you're.
Yeah.
Yeah.
Like you wouldn't need to do the import star if you do the other one.
But in a level lower, skid all was excluded from star.
What's that?
Yeah, there's actually, you're onto something that actually kind of blew my mind. It actually tripped me up in preparing this. Like this little statement here. Actually, I have some sample code on it. So if I do like let me go to the this is package assembly is what this is called. So if you look at the init.py file, it's like from .foo import star and then from .bar import star. What's actually happening there is, each one of them has this all variable that's defined. Okay, so you'll see it load, but then this statement here, I'm just going to put a note like this is odd. It looks very odd because it's like I just did an import star, but what is this like foo dot? What is like that? Just I think that's getting to your question. It just feels sort of weird or wrong or something, but.
It just feels like you could just import foo and bar without the star, and then still use the .alls.
Oh yeah. Oh. Okay. Okay. I see what you're saying. So you're thinking like an alternative where you could just say from like from dot import foo.
Yeah.
From dot import bar. Oh, the reason I'm not doing that is because that doesn't bring the symbols up.
It doesn't bring the .all.
It doesn't bring the foo up. Like what I want to do. Let me get rid of that for a second. What I really want to do here is I want to be able to say like import spam. Well, okay, bash. You're supposed to understand Python. Okay. What I want to do is just say import spam. It's going to load the stuff, and then it's going to have those definitions just available for me to use essentially. Or if you look at the the dir of spam, you'll see that those classes got loaded up. If I do that other form of import, if I did that, I'm not going to get those.
It wouldn't get them from the all.
No, the all basically only helps Python for the import star. Yeah, it's odd. I mean, if I were to do import spam with that, you would see it load, but then I wouldn't have the I wouldn't have it at like the top level. Basically, I'd have to go down one level to get that. So you definitely need that. One thing that is a little bit odd too. This statement, by the way, down below, I actually find a little bit odd as well. Like I say, like this is okay. Up here, I'm doing a from import star, and then here I say foo.all. That is not normally the way that the import star works. I mean, if you've ever done an import star, it does not usually look like that. I mean, just as an example, if I were to say from math import star, I can't come along later and just say math.sign. Like it doesn't bring the math. It doesn't bring that name math up. And so if you look at that thing here, this looks a little. It looks a little weird. The reason that this works is that foo and bar are basically sub-packages of spam, and they get created anyway. This is kind of a weird artifact of packages, but because they're submodules, if I go into spam, I mean there actually is a spam.foo, which is like that submodule, and there's a spam.bar. Those get created just in the import process. No matter how you load it, those get created. That might be more than you wanted to know, but there was another question in the back. I don't know whether it was. Yeah.
Just a question about the point before. If you do a lot of work in the init, is that a disadvantage if you only want to use part of your package later and you load all these different classes there?
I would claim, yeah. I mean, how many people have done an import on something and had to sit there for like 30 seconds? Yeah. I mean, that's a real problem. It's like you do an import and then it brings the whole universe in. I'm going to come back to that a little bit later, but yeah, that's definitely a concern where it's like if you're going to do this collection, does it import the whole universe, and how much time does that take? Another thing that I'm just going to throw out there as an alternative, in the code that I've been writing recently, I've actually been doing the export stuff with a decorator. This might look a little bit weird, but what I'm doing is I have a decorator function which just lifts definitions out of the global dictionary and just brings them up to the top level. So what ends up happening is the code looks like this instead of messing around with the all statement. So what happens is that in submodules, I would just explicitly declare like what I'm exporting. I personally like this approach a little bit better because I feel like it it's just easier to manage. Like if I'm adding the code or I'm modifying the code a lot, I always have to keep that all variable kind of synchronized with the code. I feel like using a decorator, basically, I just explicitly put on the function that this is exported. And then if I'm reading the source code, I can see it like right away. It's like, that is exported. I don't have to go look for a separate all variable. The other thing that I like about that is I can do extra magic in the export decorator. Here, I'm only doing like a simple thing, but I could actually put other things in there, like logging or validation, or there's tons of other stuff that I could use in a decorator to do things in my application. So I tend to use this kind of decorator approach. All that's really doing, again, is it's just kind of lifting symbols out of submodules and then putting them in the top level kind of automatically there. So that's another possibility there. I don't know whether that makes sense, but I don't want to dwell on that too much. The comment on the performance concerns, absolutely. Yeah, this question, should it import the whole universe when you do the init? I don't know. I think if it's like a small library, maybe, who cares? If it's some gigantic framework, then maybe. We're gonna come back to that. Now, there are some other things with init as well. I'm just going to throw out there to get thoughts on as well. Here's one question. Should you just put all of your code in the init.py file? I've seen this done before, where it's like you basically import a module and you realize, oh wait, it's a package, and then every line of code is put in the init.py. Bigger later. Actually, one place where I've seen this used is if somebody wants to have a unit test directory that sits side by side with a module. I don't show this on the slide, but you could imagine like a submodule titled test, and then maybe they have some like unit test kind of embedded in there. This just sort of feels weird to me. Maybe it's just me, or too old or something like that. But it's like if all the code is in a init, I feel like I'm looking in the wrong place, or it just feels off. I don't know whether I want to point fingers at any project or anything. It just feels kind of off. I don't know. What do people feel? Does anybody have any thoughts on it? Yeah, I think for me, it's just like I'm not programmed to go look at the init file for the location of something. It's like I would much rather it be broken out into like its own file. Like, oh, it's the connection file or something, not shoved away in the init file. So I don't know. It's a little weird. Some other things that are kind of bizarre as well. And we're going to get to this later. You can hack an internal path in packages. This may or may not be something that you've ever done, but if you import a package, like let's say you were to do XML parsing or something, it turns out that let me try to bring that up a little bit, the window up just a little bit there. Okay, so it turns out that every level of a package actually has its own path setting that gets sort of created. And what is going on there is it takes the place of sys.path when finding the next component down. So if you were to, like here, if you're looking for eTree, Python looks for it in that directory. So every component has its own path setting. It turns out that path is something that you can hack. It's maybe not totally advisable, but you can certainly go in there and append new directories on there. Like I could say, well, yeah, actually just append my current working directory onto XML path, and then if you were to do that, all of a sudden you can start doing things like, well, let's import xml.spam at this point. And you're like what? Okay, so what's happening now is it sort of picked up like that spam package from the current working directory, because that XML component of the package actually has two different routes that it can take down into finding stuff. Whether it's a good idea to hack on that or not, you can imagine scenarios where you might have a package that has like lots of different add-ons or something kind of scattered all over the file system, and then maybe somebody in a init will like reassemble those into some other some other things. So that's another possibility in init, is you can hack on that. Another thing in init, and I had no idea that this was going on, or even possible actually before doing this. A package can upgrade itself on import to a different package. Do people realize you could? I didn't realize you could do this. So it turns out that Python 2.7 has been doing this like forever. So it turns out in the XML package, in the init, what it tries to do is import an upgraded version of the XML package. Apparently there's like this XML plus package, which has like even more XML than the standard package. And then so it does a trial import, and then if it finds it, what the init does is it just replaces its entry in the module cache with this other package, and then the built-in XML module then just sort of disappears at that point. I had no idea that you could do that. So potentially you could have like, I don't know, like the free version of a package, and you could have like the upgraded version of a package, and like the import would try to get the upgraded one if it could. Again, I didn't even know you would. I didn't even think to do that before preparing this tutorial. So that's kind of one weird thing. There are other possibilities in init as well. I mean, you could maybe monkey patch things on import. You can initialize logging. I sort of feel like you should just stay away from init. I mean, maybe that's just me, but it's like in the interest of sanity, I would probably just try to keep init as simple as possible. To be aware that there are some crazy things that can go on in there. So let me just pause for a second, see whether there's questions about that. Okay. Now the next thing we're going to talk about is actually another part of Python that I did not realize all of the magic surrounding the main program in Python. You're just like, main, what are you talking about? Most people, when they run a program in Python, they just run a script. They just say, okay, Python, my script, and it runs. There is this this -m option that you might see people using, which runs a module as the main program. So it turns out if you have a package or you have any kind of module, you can say something like Python -m, spam.foo or whatever, and it will run that as your main program. One thing about that is it will basically observe things like the relative imports correctly. So actually in this spam package, let me go back to that for a second. Like this file bar that we had, where it. Well, actually, I'm going to modify bar to do like a relative import. So if I said from dot, import foo or something like that, it turns out if you do that main check or that module execution trick, it will observe that import. So if you say Python -m spam.bar, you will see it kind of load that up. Okay, so it will run that. Actually, it's kind of interesting that you get two different imports of the bar there. Sort of wondering, does anybody know the reason for that? It turns out that if you run something as a main program, that's not the same as importing it. It basically executes the code in kind of that main module space, and then if some other piece of code does an import of the same file, that's a separate thing. Okay, so that's why that happened there. But that -m module that will run something as main. It turns out that does not work. Like you can't just run like a submodule as a main program. So if you try to do that, it essentially crashes because it doesn't know how to do the relative import. So that's one of the things with that -m option, is that it observes the relative import. And that -m option is actually, I think it's actually a really useful thing. I find myself kind of using it more and more. One of the things that I'm going to rant about, you'll have to rein me in a second here, concerns the use of pip to install packages. So I have run into a huge number of cases where somebody will pip install something on their machine. They'll just say, yeah, pip install some package, and then that package is non-existent to them. like it did, like a whole bunch of stuff kind of went out on the screen and like it printed out and it said installed successfully, and then they try to use the package and it's not there. And then they're kind of scratching there. Has this happened to anybody here where you like pip install something and then it kind of went and did its thing? It's like, what the hell, where'd it go? The thing that is going on there is that oftentimes the pip command is not tied to the version of Python that you're actually using. Like if you have multiple versions of Python on your machine in like different development tools and so forth, you may actually have a case where pip is not tied to the Python that you're actually working on, and then you have no idea where things go. So I actually kind of prefer this first version where you say Python -3, -m pip. What that does is it explicitly uses the version of pip that is that version of Python. It's kind of tying the two things together, so to say, I'm using that Python, and I want you to install into that version of Python. So I find myself kind of using the -m option quite a bit. There are actually a variety of other tools that use that -m, by the way. I mean, there are things like the web server module. If you ever want a web server, you can just say Python -m, HTTP server, and it will like run a web server on your machine. There's debugging modules, and there's all sorts of things that tie into that -m that are kind of cool. Another thing that is also not widely known, if you have a file called main.py, this will designate the entry point for a program. So for instance, if you had that in a package and you do a Python -m on it, Python will just immediately go to the _main file. I'm not sure when this got added to Python. It kind of caught me by surprise, actually, somewhat recently, that you can do that. Okay, so main is an entry point. One of the things that you can do is use that to make maybe like submodules executable. I actually do this in a current application I'm working on where I have a directory structure of modules or subpackages, and some of them are sort of independently executable. Maybe there's like a test directory that's executable. Maybe there's a server directory. By putting a main file in there, I can essentially just run that submodule, and it will just start running. Yeah.
I've used it when hacking some like little applications with zip file, and then the main just run the zip.
Oh yeah, I'm going to get to that. That's actually something that's really cool, by the way. But let me get to that in a second. So I mentioned that a number of tools actually use that -m option to their advantage, by the way. Now the question that was just brought up, this is something I think is pretty cool. Did you know that if you have a directory of Python code and you just put a main file in there, Python will execute the directory like a script? I didn't actually realize this until recently, actually within the last year. I mean, I've been programming Python for a while, and I don't know where I read this, and I was like, wait, you can do that? That works. So, so as an example, like this, like this spam, folder here, this is that. If I were just to make like a main file in there, I don't know, just hello world or whatever it is, I'm going to get rid of the init file. Just get rid of that. Get rid of init. Okay, so let's say we have, and I'm going to get rid of the PyCache. We'll talk about PyCache in a second. So let's say you just have like a directory of code like that. That's not even a package. It's just a bunch of Python code in a directory. You can just come in here and just say, yeah, Python spam, and it will just run. Python looks for that main file, and if it finds it, it will run. Now the thing that additionally blows my mind on this is that if you make a zip file out of that, like let's say I say Python -m zip file create -m option again. I don't know that you knew Python can make its own zip files, but if you need to do that, you can say okay, Python -m zip file. If I say spam.zip, and then just I'm just going to pull all the .py files into that. So actually, let's just get rid of the spam directory at this point. So now I have like a spam.zip file. I didn't realize that Python could execute that as a script. No, it's like, huh? All right, kind of interesting. It actually gets even better than that. You're gonna love this. Going back to spam. Okay, so I'm going to do the usual shebang thing here. Okay, so we're going to do that. I didn't realize that you could cat the zip file onto the end of a shebang script. You're like, what did Dave just do? Okay, so now what you've got is you've got the Python 3, and you have a zip file just appended onto the end of that. And then I'm going to make that executable. And then I'm going to get rid of the zip file. Okay, so now I just have like spam. I didn't realize that would run as an executable. I'd never seen that before, and apparently that has been around since Python 2.6. So if you're looking at that saying, oh, that's some weird Python 3 magic or something like that, it's actually been around for like 6 years or something. There is a PEP on that right now with this, I think it's PEP 441 or something, that is trying to clean that up a little bit, or to better specify that. I think they're talking about making like a PYZ file or something that does that, but is this the kind of thing that you're doing?
I just happen to do it for one thing where I need to package up a little launcher kind of thing. And it's just easy to zip it, give it to somebody, and have them run it.
Yeah.
Just think about what type of code it was.
Yeah, I mean, I find that kind of disturbing. It's like, especially that it's been there for so long. Like, it's like, oh, Dave, you wrote a Python book and you never saw that. I mean, it's like, where have you been living the whole time? But that's it's kind of mind blowing. Just take like a zip file, drop like a shebang on the front of it, and just give it to it's like all of a sudden it's like an executable. I had no idea. All right, so yeah, so everybody's going to walk away from this tutorial and start doing that. I don't know, the world will collapse at this point. So some fun stuff with main there. Let me see if there's other questions about that before we go on here. Okay, now what we're going to get into next. Yeah, okay, we're moving into the hell part of that painting from earlier with ears being cut off and so forth. I want to talk about sys.path a little bit. So pretty much every problem concerning import ultimately seems to come down to that sys.path variable. At least the questions that I get with people new to Python and coworkers and things like that. It's it's like, I installed something, it won't import, or won't import my file, or whatever. And kind of the short story: if your code is not on the path, it's not going to import. End of story. It's like that. That is kind of like the ultimate sort of thing that's guiding things. And it turns out that the management of that path is just absolutely insane. Like if you look at all the steps and things that go into that, so we're gonna kind of try to break that down a little bit. So kind of at the high level, that path variable is just a list of strings. It's like directory names, it's names of zip files and so forth. Python just walks it start to end. First match it finds, that's what it imports. Okay, so conceptually, it's a really simple thing that's happening there. A few just little odds and ends. Again, zip files can be added to that, and they work just like it's a directory. So, no problem adding a zip file on there. Egg files are actually just zip files, or they're directories. So if you've ever wondered, like, what is an egg? It's either a directory of code, or it's a zip file just with some metadata in there. I'm not going to talk further about that, but I mean, that's what an egg is. There are certain types of things that Python is going to look for when you do an import. So not only is it going to go down this path, kind of looking for things, it's actually looking for all sorts of stuff. It's either looking for packages, it's looking for C extensions, Python files, compiled Python files. One of the things that you can do if you ever want to investigate this is run Python with the verbose option, or -VV. And it will show you everything that it's trying to import as you do import statements. So if you were to import some module, I'm trying to think of something. Well, let's import like regex or something. So if you were to import RE, oh, it's actually already loaded. Well, let's load socket then. You're gonna see it basically trying different kinds of files. Like here, it's basically testing different things. Like, is it an SO file? Is it a different SO? It's looking for things like C extensions. It's looking for PY files, it's checking caches and so forth. So you can actually see what it's doing, and you can actually see it traversing kind of different library directories as it goes. So it's looking for these in things like the current directory, and then working its way down the path. So you can investigate that. Probably worth checking out a little bit. And then so that's what it's doing. Now the insane part of this actually concerns how that path variable gets put together. So that sys.path setting, again, that's like the end of this. That's the whole story on import. If something is not on that path, it's not going to import. And so if you look at it, you're going to find like different directories on there, and how that actually gets put together involves a lot of different parts. And so I'm going to kind of step you through that, and there's kind of a reason for doing this at the end. So it turns out that Python, in kind of its basic configuration, just puts 4 entries on that path. You can actually get this if you run Python with the -s option. So what that will do is it will just start up Python with its basic configuration. It's like, okay, there's the path. Standard library. What is happening there is a setting in Python that sort of determines its location. Okay, so there's this prefix variable that just sort of defines, okay, where is Python installed? And ultimately, that's actually coming from sort of the location of the Python binary on your machine. So if you look at the value of that prefix, like on my machine, it comes up and says, "Oh, user local." If you ask it, like, well, where is Python installed? User local. Okay, so it's kind of tied into that like location where I'm running Python. There's this prefix variable, and what happens is that prefix is used to form the initial path entry. Okay, so there's kind of hardwired to kind of construct that, where you'll get these 4 directories kind of set up. Oh, there's one other value here. This exec prefix, by the way, is used to do the location of compiled C code. This is things like shared libraries and DLLs and so forth. They end up going there. And so what happens is that prefix is used to kind of determine like the initial path, but then there's a whole bunch of customization that ends up getting built on top of that. So it turns out that prefix is something that can be modified or played around with. This is actually the basis for things like virtual environments. So if you've ever used virtualenv or any of those tools, they're actually messing around with this prefix setting to relocate Python to a different place on your machine. Now, some of the things that you can do, okay, so let's talk about kind of the space of what's possible. Turns out that there's an environment variable that will just relocate Python entirely. Just as an example of that, if you say environment PythonHome equals, like dot or something like that, and you try to run Python, you will end up breaking Python. Okay, so actually that's really, yeah, okay, cool. It's like, so it basically crashed immediately, sort of saying, I can't find the Unicode, I can't find the encodings module, and then like it just aborts. I love the red message in there too. Great. Okay, so what is happening there is that Python just cannot even find its library. It's like, I have no idea. All right, so you're sort of stuck. If you wanted to make like the worst virtual environment in the world, and I'm not going to, don't do this, by the way. You could copy the Python library. Like you could just say, okay, actually, I'm just going to copy. Well, actually, let's just make a directory lib, and then I'm just going to recursively copy the user local lib Python 3.5, and I'll just copy it there. This will take a second, but it won't take that long. So again, don't do this in practice, but we'll talk about what's happening here. Okay, so if you were to copy the Python library to kind of its own, like to your own directory, if you will. Dramatic pause as it does that there. You want to use symbolic links? Oh, will it follow it if it's a symbolic link? Maybe. But that wouldn't make it easier for you to hack on it. Like maybe you need to monkey patch the standard library by copying it to your own. No, don't do that. No, so if you were to copy it there and then run this statement again, Python would come up and it would say, oh, okay, Python home, I'm cool. I found my library there. So if you were to look at the path at this point, you're going to see it. Python basically relocated entirely into a different directory structure. I mean, it found the library. That Python home variable is essentially controlling that. So that's one way that you can control sort of the location of Python is through that. Now, again, don't copy the library. We'll talk about a better way to do that. So that's one thing you can do is that. Another thing that you can do is simply copy the Python executable to some new location. And it turns out if you do that, it will look in its surrounding environment for the location of the library. Again, I'm not going to recommend that you do this either, but if I were to make like a bin directory here, and then I were to copy the Python 3 executable in there, okay, so I'm just going to copy it into bin. Like that. Okay, so the bin directory just has Python 3 in it. If I were to run that, okay, Python 3 bin, it would start up, and you would actually find that the whole thing has been relocated. Like if you looked at the path, it would say, oh yeah, I'm actually running out of that directory. The whole reason that works, essentially, is that Python is looking for the location of some hardwired landmarks. There's actually only 2 of them. It looks for the existence of the os.py module, and it looks for the libdownload directory. So what happens is Python will look at the executable, and it'll say, okay, I'm running here. I'm going to go up one level. I'm going to try to find a lib directory, and I'm going to see if I can find those. And if I can find it, I will set the path, that prefix, accordingly. It's actually a little bit more insane than that. Python will actually look at every directory all the way up to the root level of the file system for its library. I don't know whether that's a good idea or not, but essentially it gets like a starting point and then it just starts stripping path components off, looking for the library. And once it finds it, it will stop. There's probably some kind of evil that could be done with that, although I'm not sure what. Last resort, that the location is hard-coded into Python. Okay, so that prefix setting, there's like this whole sort of setting process that's taking place there, and messing around with this is kind of the foundation of things like virtual env. Okay, so Python 2 virtual env. I'm not going to say so much about that, but it does rely heavily on kind of this idea. I mean, when you make like a virtual environment in Python 2, it sort of sets up a structure like that. And then the Python executable, it is able to relocate itself to that directory, essentially. So that's what's happening there. Python 3 actually has a different virtual environment setting in that's trying to clean up some of the process for that. I'll say something about that in a second. But like controlling that you can control where Python is installed basically. Now some other things that go into the path. We're actually not done yet. You can put an environment variable that gives extra directories. So you can do a Python path environment. Those will actually just get prepended onto the front of sys.path if you provide it. Okay, so you can do that. Sometimes I'll do that if I don't know, I have Python code kind of installed in a weird location and I don't want to install it anywhere. I mean, maybe I'll hack on that. So you can do that. And then you get into the problem of third-party packages. We haven't even talked about that yet. So in order to do third-party packages, there's a module called site.py that gets imported to add additional directories to the path. It turns out that Python -s option that I did does not import that site package or that site module. So what happens is the sys path sort of gets minimally set up, and then if you import site, you're going to see additional things get added to that. Actually, okay, interesting. Well, the site is supposed to add. I'm kind of curious that Okay, well, let's not go there. So the site package basically is adding like additional directories onto the path there. And the main directories that it's adding are these site packages directory. Okay, so there's one actually for you as a user. So there's like this .local lib python 3.4 that's like for you. And then there's a system-wide site packages. This is where things installed with pip are going to go, or easy install. So if you're doing any kind of package manager or package install, it's usually going to go into one of those locations. Some Linux distributions add an additional path, like dist packages on there. I don't think that's an official Python feature. It's some added thing that they're doing, but that's essentially where packages are going to go, is into those directories. And then, just as an aside, if you ever have to debug an installation, that's where you would look to sort of see if it went there. Basically, you could look in site packages. And then you get into this topic of virtual environments. Okay, so Python 3 actually has the ability to make a virtual environment as part of the language. It's no longer like a standard. It's no longer like an add-on package. So what happens with that? Actually, let's do this and take a look at what happens. So Python 3 has this command where you say Python 3 -m v-invent virtual environment. You give it a name. Okay, so let's make the name PyCon or something. What that will do is it will essentially make a new directory structure that mirrors kind of like a Python installation. Okay, so there's like you go into PyCon, you have a bin directory where you have a certain number of tools. Okay, so you have Python and you have pip and easy install kind of put in there for you. You have the lib directory where you have the Python 3.5 library. Interestingly enough, the only thing in there is site packages. So what you end up with is a library that is just like an almost empty site packages. There's a few things for pip and easy install in there, and that's essentially it. So you end up with kind of an empty library directory, and I don't think the include directory has much of anything in it. Yeah, nothing. Okay, so you kind of end up with this directory structure. It has a few minimal things, just the Python executable, a mostly empty lib directory, and then you end up with this configuration file here. Let's take a look at that. Okay, so you end up with this config file. What this is doing is it's sort of telling Python where the original version of the standard library came from. Okay, so it's sort of saying, okay, well, this was actually created from user local bin. And then there's a few configuration options. What's gonna happen with this is that if you run the version of Python that's in the bin directory and use the right command, okay, that always helps. What's going to happen is the sys path is actually going to be using the original installation of the Python library. Okay, so if you look at this, you're going to see the original paths kind of inserted there, but then all of the third-party modules are going to go into this like custom directory that I just made. So you'll see that you have this PyCon lib, Python site packages. That's where all the third-party modules are going to go. And one of the things that you'll see is that none of the original directories are there. Like the system-wide site packages is not there. The one that's in your user like home directory, that's not there. It's essentially just a completely custom directory at that point. Okay, so that's what's going on in a virtual environment. Is essentially that is creating just a completely new kind of directory structure. Only a few files in there. But what happens is that new site packages is where it's going to start installing stuff. I don't know whether I dare install anything at this point in the tutorial, so you can take my word that works. But that's what's happening there. Let me see if there's questions about that. Everyone cool with that? Okay. There is an option on virtual environments, by the way, to also use the original system directories as well. So if you create one of these things and say that you want the system site packages, you'll get all of them. So you'll get the ones that everything that's already installed, plus your own directory there. Now there's some other things that come into the picture. It turns out we're not done with that path thing yet. So it turns out that Python, when it's like setting up, looks in the site packages directory for the existence of these PTH files, like PTH, what is that? What is going on here is that if you go into any one of these site packages directories, actually I'm just going to go into the one that I just created here, okay, site packages, and if I make a PTH file, because I'll just make some file foo.pth. If you add directories in here, they will just get added to the path. I don't know why I would do this, but like if I wanted to add like Etsy and temp to the Python path or something, I could list them there. And then what's going to happen is if I run that version of Python, we'll see if this works here. Oh, I'm not even using the right name. Okay, so let's say you were to run that, okay, version of Python and then import sys. One of the things that you'll find is that the directories that were in that file just got magically added onto sys.path. I'm actually a little curious. Have people encountered these like path files before or seen that? There are all sorts of kind of opportunities for evil with that, by the way. Like if a third-party package wants to install its own PTH file, all of a sudden, you know, like Python will start importing code from non-standard locations. You could imagine all sorts of things going on with that. So you have these additional files that are basically adding directories on there. One of the uses of those is by package managers. So it turns out that if you've ever looked at your path and you've seen things like egg files and stuff added on there, what is happening is some package manager like pip or easy install is using a path file to basically add those. I wonder if I could see that here, like not to bring Python 2.7 into the mix here, but if you were to look at like the path in Python 2.7, I see a lot of stuff on there like added. Okay, so I have like, you know, click and SymPy and scikit and like, so there's a whole bunch of things that are being added to the path. Those are actually being added by some kind of path file in this user local site packages directory. We could go in there and check it out. Okay, so let's just check it out. So okay, so here's one. There's like an easy install path PTH. That might be where it's getting set up. I don't know. Let's take a look at it. Okay, so there's a couple of entries on that. Okay, so that's where those things are getting controlled. Basically, there's PTH file that's adding that. When you install things into your system, one of the package managers might be appending to that or editing that file to do that. Now it turns out that it gets even sort of better than this. As if there wasn't enough magic already going on with the PTH files. It turns out that any statement that starts with an import gets executed as code. Just sort of weird. Like in that file, if you have anything that starts with import, Python will just execute it. That can actually be used to do even more magic with package managers and so forth. That feature has been around Python for a while. I actually tried to dig that up, like where that came from. It originates from 2001, believe it or not. And the original 10, you might not be able to read that in the back, but was to do like registration of Unicode codecs and things like that. Because otherwise people would have to edit the site.py file or something. So it's kind of a way of doing kind of magic on startup. It's since been kind of co-opted by a lot of the package managers to do things. So you get that. And then if that wasn't enough, it turns out that there's also two other directories that come into play. There's basically a site customize module that you can write and a user customize module that you can write that may do additional things to this path variable if they want to. And then at the end of that, your current working directory or the script directory gets added to the path. So we kind of got, it's like, I think there's like a fairly high degree of like insanity basically going into this path setting, or it's like, it's like being set by Python. There's environment variables, there's these PTH files, there's like package managers, imports, all sorts of stuff kind of go into setting that up. Why you might care about it is maybe if you have to debug an installation somewhere or a deployment, you're wondering like what is, what's going on with Python. You might have to dig into that kind of stuff. One other thing I didn't realize as well. This is sort of, I don't know how long this has been around, but if you run Python with the capital I option, it locks out most user customization. I don't know when this got added, but if you do that, it ignores pretty much all user environment variables and site packages and so forth. It might be useful if you were writing maybe like shell scripts or something and you didn't want the user kind of messing with them. Maybe you could use that. Again, I'm not sure how long that's been around, but discovered it and doing the tutorial. And then again, package managers, they love to kind of play in this space. So if you're using pip or any of those things, they're essentially operating in this environment and using that to kind of work there. So let me see if there's questions about that. I'm getting the sense that there's probably a coffee break at some point, kind of coming up as well. I don't know when that's scheduled. Does anybody know when that's?
25 minutes.
What?
25 minutes.
Is it scheduled in 25 minutes or does it? Okay, so at 3 o'clock. What?
At 3 o'clock.
Okay. All right. So let me see if there's questions, and then get into something more insane here. Okay. The next thing we're going to talk about is another kind of wild thing with packages, something called a namespace package. And to introduce this, I'm going to start out by saying you don't actually need the init.py files anymore. It's like, all right. So it turns out if you have a directory of code, like just spam, and you have 2 files in there, no init. Okay, so there's no init file anymore. Python 3 will actually treat that as a package. It'll work fine, actually. You can say import spam.foo, spam.bar. Works perfectly okay. This is actually probably the feature that Python users have wanted forever. Oh, I hate those init files. Why do I even need those? Turns out you don't actually need those. However, if you do this, you are opening up your code to a very exotic form of magic that a lot of people don't know about. So what happens if you do this, you're going to end up with something known as a namespace, essentially. Okay, so if you do, let me see if I can find an example of this. Okay, so go up to the code directory here. Oh, okay, module package. So I think I have a namespace package. Okay, so I'm just going to go into one of these directories. Okay, so here is a directory spam, and it has a single file in it bar. Okay, so I'm trying to resize my window a little bit to bring it up. Okay, so I have a directory spam. If I ls spam, there's a file in there. It does not have an init file. Okay, so no init. Python is perfectly happy importing that. I can just say import spam.bar. And it's like, great, no problem. This does not work in Python 2, by the way. So, don't try that. But if you look at what spam is, it'll come up and say, okay, I'm a namespace. Okay, interesting. What is happening here is Python will let you have multiple directories on the sys path, and it will combine them together into one package. This is a kind of a pretty exotic thing, but let's say you had 2 directories, like you had spam foo and you had spam bar. They both have a spam directory, and they have different files in there. Okay, you have foo.py and you have bar.py. What will happen is those 2 directories will unify into a single package. Magically, you don't have to do anything for this to happen. So just to see that, I'm going to go up one level here. Okay, so there's my let me go back, namespace package. So I have 2 directories there. I have a spam bar, spam foo. They essentially both have spam directory in there. Okay, so they both have the same directory in there. If you were to edit the system path, okay, so I'm just going to come in here and append, well, actually, I'll just use extend. Like if I were to extend the system path with those two directories, like that, I'm actually going to, you'll actually see the two things unify together. Like if I say import spam bar, that will work. If I say import spam.foo, it will work. And those two files are essentially coming from two completely different places. Okay, so they're coming from two completely separate subdirectories there. Yeah.
From each other's standpoints, is like, does foo see bar? Does bar see foo?
That's actually a really great question. I don't know. So like maybe like what if foo were to do like a relative import to the other one? That's a great question. Let's try that. We're gonna live dangerously here. Okay, so we're gonna come up here and we're just gonna assume that the well, just from dot import bar. Just to be clear, it's like it's coming from somewhere, but it's not my directory. That's coming there. Okay, so let's try that. You're kind of an evil person for thinking that. I just kind of appreciate that. Okay, so we're gonna put these back on the path here. That's actually one thing about some of these features of Python is that you enter kind of a weird gray area where you sort of wonder about that. Okay, so what I'm going to do here is try to import spam.bar, or was it well, boo. Wow. Okay, so yeah, all right. So that worked. It actually gets more. Okay, so what's happening under the covers, by the way, is that this spam namespace, if you look at the path of that, it essentially lists, what happens is that Python will scan the normal sys path and find the duplicates. Like it will know that there's two duplicate spam packages there, and because there's no init file, it sort of says, oh, actually it's safe to combine these, and it will merge them together. Yeah.
So what if there was an init file on one of them?
If there's a init file on one of them, I think all bets are off. I think it picks the one with the init file. We could try that maybe we'll try that in a second. Yeah.
And if they define symbols with the same name?
If they have things the same name, I would guess that they go in the order of sys.path.
You mean the reverse order, so the later import overwrites?
Yeah, the question is, does the later import do the... I would guess it would go with the first import. Like whatever the first entry on sys.path is would probably go first. Yeah, yeah. One thing that's odd about this too is this is dynamic as well. I'm going to try to illustrate that. Like if I were to make like another directory, again, I'm doing this without quitting Python, by the way. Okay, so if I make a directory, another directory spam, and then put a I don't know, file grok in there. Okay, very sophisticated coding here. Okay, so another file there. If I were to come back to Python and then just append that onto the path, so I'm going to append that onto syspath. What's going to happen is if I try to do import spam.grok, it's like, oh yeah, okay, that's cool too. I mean, what's going to happen is that path variable at the package level automatically gets updated to find that. I'm trying to resize here. It gets updated to find that new directory. So there's a serious amount of kind of magic going on with that, where it's like, huh. It's like updating that path dynamically. It's unifying directories together, and so forth. The question of like the duplicate entries. Yeah, I don't know whether you want to explore that or not. I'm pretty sure it's gonna go in order of those directories, and it would find the one that came up first. Yeah, was there another question in the? in the back. And then the subject of the init file, by the way, let's do that. I think if any one of them has an init file in it, it takes precedence. So let's say I were to do it, I'm going to put an init file into that grok directory that I just did. If I were to come back and put these on the path, okay, so sys.path extend. So the thing I love about this is actually all these weird corner cases that immediately pop up at this point. Like, what if there's duplicate entries, or what if there's an init file? And you sort of realize that you're entering kind of this world of madness and thinking about that. Okay, so I've added 3 directories there. If I do an import spam, it no longer identifies itself as a namespace and just comes up and says, actually, I'm spam.grok. It turns out that the init file will single-handedly sort of disable this feature. So you will not find that. It won't be doing the unifying anymore. So it's actually a critical feature of this that you do not have the init file. All right, everybody still with me on that? Now you might look at that and say, okay, what am I? Okay, what am I going to use that for? Okay, so I'm talking a little bit. I'm just talking about the mechanics of how that works. I mean, essentially, what it's doing is that it's collecting all the directories that have that package name and putting it onto the package path. So there's a fair bit of magic kind of going on there. Now, as far as using this, I think kind of maybe the main use of this would be for framework builders who maybe want to have a plug-in system or something. I mean, I could imagine a scenario where it's like, okay, I have this huge framework, and I want to have like an area of like user-contributed modules or something that people install separately. Maybe you could use this to do that as sort of a whimsical counterpoint to the medieval. The medieval painting. I thought I would do an example involving the Teletubbies. This is the if you're not up on your Teletubbies, you just need to get like a 2-year-old or something. So let's say you wanted to build like a user extensible framework of some kind. So I have this package called Telly here. Okay, so what is going on in the framework is there's essentially a framework core of some kind. Okay, the Telly framework, and maybe it has an init file. Okay, the top level has an init file, but somewhere in this framework, there's going to be like a plugin area. In the Teletubbies, they live in the Tubbytronic Superdome there. So a little trivia there. So let's say you have like a submodule called Tubbytronic there, and let's say the purpose of that plugin area was maybe there's going to be like some built-in plugins. But then you're going to allow users to install third-party add-ons or something like that. So what we're going to do is we're going to have maybe like user plugins that they can drop in their home directory or something. So you tell the users, it's like, yeah, okay, you can have like your own plugins, and what they're going to do is make like the plugins will each have like their own directory. Where they'll just say, okay, I'm in .telly, and then there's like Dipsy and Poe, and they each have like that Tubbytronic directory there. Keep in mind, these are not part of the main framework. Like the framework is its own thing. This is some extra add-on thing that's going on here. So they're not installed as the main package. And what we want to do is just take all of the plugins and just unify it into the same namespace. So what's going to happen from the user point of view is they're just going to always import things from like that Tubbytronic directory. And they actually have no clue about what's going on under the covers. They just know that all plugins are in Tubbytronic. However they get installed, that's what's happening there. So if you wanted to do that, I'm not even saying this is a good idea, by the way, but if this is the direction that you wanted to go, what you're going to do is essentially take like multiple directories on the file system. Okay, so here we have the main package, the Telly package. Again, it has its own It might have its own modules that live there as well. And then you're going to have these two other directories there. And what we're going to do is essentially try to make it look like one logical Python package. So the user, from their point of view, is only going to see one directory of code, even though it's spread out over multiple places. To do that, the strategy is essentially to make one of these namespaces. What you could do is in that init file, at the top level, like this top level init up there, I could essentially create the path that kind of collects all of these like plugin directories. So I'm gonna start with that. You could actually do this programmatically. Actually, I'm not gonna talk through the code necessarily, but what this is doing is it's just looking for like the .tele directory, and then it's collecting all the subdirectories and just putting it on the path. Okay, so you could build up that path, and then it turns out that magically, this whole thing will work. It's like what will happen is it will turn that submodule into one of these namespace packages, and then everything will just sort of unify. It's kind of, I mean, it's kind of insane actually, but it's like you're unifying directories into a common sub package like that. I'm actually curious. I mean, how many people have seen namespace packages before? Believe it or not, this is an old idea. Setup Tools has stuff for this. So if you've ever used Setup Tools, there is support for doing this in kind of a somewhat more roundabout way. So it's actually not a new idea. It's been kind of floating around for a while. What happens is that Python 3 is actually kind of more formalized it into kind of a core feature of the language, that it will do this unification thing. Yeah.
You did import star. Did you get all of them?
I don't think the import star works, because the import star kind of relies on like if you said from like, you know, tele dots, like from tele.tubbytronic import star. In order for that to work, it has to pull symbols out of an init file, and since there's no init file, I'm not even sure what it does, to be honest. Let's try it. I actually have this tele example kind of pre-packaged for demo here, so like that's actually a really good question. So Python 3. Let's just import. Okay, so I'm gonna. First of all, just make sure that it's actually there. Okay, it does say that it's a namespace. It does have 3 packages on there. No, that's actually yeah. I actually don't know. So your proposal, you want to say from something like from tele.tubbytronic import star.
Yeah.
I actually have no idea what this is going to do. I mean, it did something. I'm not sure it did anything useful. That's the problem. So yeah, it's like the contents of that module are supposed to be files like, you know, there's like, I think there's like a PO module and so forth. So yeah, I'm not even sure you can do, like, it will run, but I don't think it does anything interesting. And the only way to make it do something interesting would be to have an init file. And then by having an init file, you disable the namespace package. So you're kind of, you've got your head kind of tied in a knot at that point, and so forth. So yeah, this namespace package stuff. I mean, I think it is a little on the insane side. Yeah.
So the relative imports work, but if you import star, it doesn't.
Yeah, the relative imports work, but the star doesn't. No, but you could do the star one level down, right? I mean, you could say from like tubbytronic. That almost makes me feel more silly than saying dunder. Actually, okay, tubbytronic. Okay, so I mean, you could certainly drop down one level and get that. It's just like you can't do the star on that level where you're unifying things. Oh, the verbose. Yeah, that's a great idea. Like the -VV. Okay, so what do you want to import? We're going to do tele.
With the star.
Oh, with the star. Okay.
Right.
Oh, that's kind of interesting. It talks it. Let's see. Is this giving us the? Okay, it's finding that. You see it trying a bunch of stuff. Well, actually, there's some actually kind of some interesting information here. One of the things that you're seeing in the verbose is that it's actually coming up and saying it's actually a possible namespace. Like it's sort of saying that Tubbytronic, it looks like a possible namespace, but here's the thing. It doesn't actually know that it is a namespace until it can verify that there's no init files floating around. We did that example where if you had an init, it sort of shut the whole thing down. So what actually happens is it sort of identified that, sort of saying, yeah, it looks like a namespace because there's no init, but then it actually keeps going through the other directories. Okay, so it comes down here into a new directory, and it comes back and says, oh, actually that looks like a possible namespace as well, and then it sort of continues on and says that that's a namespace. It doesn't provide any more information, but you sort of see it kind of scanning the path, kind of collecting these, like the Tubbytronic directory, if you will, before actually making that.
Right. The only QI file it's looking for is Tubbytronic, which doesn't exist, of course. It's a
Yeah.
file.
Yeah, I think the possible namespace is because it found a directory called Tubbytronic. So there, it basically found a directory with that name, but there's no init file. So it's sort of saying, well, okay, it looks like it might be a namespace, but it has to check the whole path to verify that. The thing that I kind of wonder about this, we'll do a break in a second, is just, so this is stepping way back, the fact that package imports work without an init file now seems like it opens up kind of an interesting area for newcomers to Python. So here's the scenario that I can imagine. It's like somebody's new to Python, and they're like, oh yeah, I can just put my code in a directory, and I can do these hierarchical imports. It's cool. It's like, yeah, it's awesome. You just take a directory of code, and and you just say import spam.foo.bar or whatever, and all works without having any awareness of what kind of insane magic is underlying that. It's like if you're importing out of directories with no init files, there's a whole bunch of stuff going on with Python looking for other matching directory names and like trying to unify things. I mean, I don't know. I could imagine a scenario where somebody wrote code without the inits, sort of happily unaware of this, and then it probably works fine like 99% of the time or something like that. But then when it does fail, it's going to be utterly spectacular. Like, it's going to create this gigantic sort of bug in their system, and then they're going to go down that rabbit hole wondering like, God, what in the world is going on? Not realizing there's just this madness on the path and all this collection of stuff going on. So I don't know whether that would happen or not, but I could certainly envision that being something that would take place. All right, now I think with that, it is definitely coffee time. So when we come back, we're going to talk about some internal stuff with modules. There'll be some cool hacking of stuff. So, but why don't we take a break? I don't know how long the break is. Does anybody know? Is it 15? Okay, 15 minutes. All right, I'm gonna go ahead and get started. So, yeah, actually, one question before the break, somebody came up here and it's like asked, so the namespace package stuff. It's like it's kind of cool, but should you be doing that? I think that was the gist of the question. It's like, is that something that you should be doing in your program? I have no idea. I mean, I'm actually would be really curious to get like if people had opinions about that. Like having seen that, does that jump out as something like, oh, I'm definitely going to do that, or does it go the other way? Like I am definitely not going to do that stuff. I don't have a good feel for that. The fact that that feature got added into Python 3 sort of tells me that it must have been important enough for somebody to write a PEP on it, and they must have pushed for it. I mean, I mentioned that this was something that was going on in Python 2 for a while. I don't think it's the kind of thing that you see in sort of simple Python code, though. I mean, it's definitely more, like exotic framework stuff that would be doing that. All right, so everybody ready to continue? All right, so we're getting into kind of the crazy hacks part of the tutorial. So we're gonna be looking at more code in this half, but I think kind of a big focus that we're going to do is talk a little bit more about the underlying machinery of the import statement and some other stuff. And the first thing that we're going to talk about is just what is a module exactly? I mean, that might sound like a weird question, but it's like, okay, so let's say I'm in Python and I say, I type import socket or something. What is that? It turns out that modules in Python are basically an object. Like if you ask it, like, well, what's the type of socket? It says, I'm a module object. You can actually create modules yourself if you want to. I mean, there's the like the types module that you can import. You can actually just come in here and say, yeah, actually, why don't I just make a module type, and then you give it a name like spam. Done. You've made a module. Okay, so a module is something that you can just kind of create on the fly if you want to. Underneath the covers of a module, it's basically just a dictionary. That's it. There's a few predefined variables in there that I'll talk about in a second, but it's a dictionary. And if you do any kind of operation on it, like you say mod.x is 42 or mod.x is .x, you're just modifying the dictionary. Okay, so it's actually a lot like a Python object, really. It's just, okay, module, it's a dictionary. You can set and delete attributes and so forth. Okay, so that's the kind of the basics. It's something you can make.
With creating a module like that, would that come out of cache?
Yeah. Question is, does it come out of the cache? The answer is no. If you want to make a module, you can make a module object whenever you want. If you want to put it in the cache, then subsequent import statements will find it. But yeah, you can just make a module just kind of out of, like the module object out of thin air. And again, all a module really is it's just a dictionary in disguise. I mean, it's a little wrapper around a dictionary, and the common operations with the dot are just manipulating the dictionary. Now there are some attributes that get set up. Like the name variable is basically the name of the module. There's a file setting that sort of tells you where it was located. There's some other things that you can set, like a doc string. Some of these other variables, like path and package, are two variables that pertain to package subcomponents. It turns out that if you're in a package, the package variable just tells you what the name of it is. So if you were to import, like XML or something, and then look at its package variable, it would say I'm XML. If you look at the main interpreter here, there's nothing set because you're not in a package. It turns out that package variable, by the way, is what solely determines the relative import statement. So if you were to say something like from import from import telly or something, which I think is what we were working on last, it basically complains saying, well, you're not in a package. It turns out if you were just to set a package, actually I'm not really sure what this is going to do, but like if you were to set a package variable, I don't know, just set it to spam, and then I tried to do that relative import, you'll actually see it try to execute that. It's a little bit confused because I don't have a spam loaded up or anything like that, but it's like that package variable enables the dot essentially.
So you can make your current package XML and then try that again.
So the suggestion is make the package named XML and then try it again. I have no idea what that's going to do. It will probably, yeah. Well, actually, what we probably could do though is we could import from .import etree. That's part of the XML package. The reason that works is I'm telling Python, hey, by the way, I'm in the XML package. So so that package variable, I would not suggest tweaking that, by the way. So that just sort of tells you if you're in package or not. And then the path variable also gets set to look for package subcomponents. So packages basically set those. Otherwise, a package is actually just a module. There's no it's modules all the way down, or module objects all the way down. So they're really kind of the same thing. Now, as far as what import is doing, it's actually hard to describe just how dumb import is in some way. I mean, literally, what import does is it just creates a module object, and then it execs the source code in the module, and it like puts it in the module cache. That's basically it. In fact, this is the code for it. I'm actually just going to go to this code and kind of show you this. So I wrote this thing mini import. Okay, the mini import. So this is like a tiny implementation of the import statement. All that it really does, let's just focus on this, is this. Essentially, you take the module name, you drop a .py on it. Keep in mind, this is like a really stripped down version. So you just take the module name, you drop a .py on it, you open it up, and then you literally just sort of exec it inside the module dictionary. So what happens is you create a module, you compile the code, and then you just use the exec function. People hopefully know about exec, right? You just give it a string of Python code and it like executes it. That is basically what import does. Like if you take just that simple code, sort of all by itself, you know, I'll just run that interactively. So I have a function, you know, spam is equal to import module spam. It's like done. It's like there's my module. So there's actually not a huge amount of stuff that goes on there. It's just like find the file, exec it. Now there are some things that build on this though. One of the things that builds on this is just what is a PYC file. So what happens with PYC files is Python will compile that code. If you don't know about the compile function, by the way, just if you've never seen that before, let's say you have some piece of Python code like that. Okay, so there's a piece of code. You can use the exec function to run that. You can use the compile function to compile it into bytecode. Okay, so if you say compile code and then you give it maybe like a file name or something, along with the fact that it's exec, it will turn into a code object. This is actually this is basically the low-level like bytecodes that Python executes. If you ever want to see what that is, you can disassemble it using the dis module, and it will show you the Python code or the bytecodes that underlie that. So compile is essentially taking like your source code and like turning it down into that. That's what Python runs when it's running your script, is that. And so what's happening with PYC files is Python just takes the code, compiles it, and then it's actually just written out to a file where there's sort of a magic header on it, along with a modification time and a size, and then it just uses Marshall to basically dump that out. That's it. That's all PYC file is. The modification times are used to know when to regenerate those. Okay, so if you've ever wondered about PYC files, that's all that's happening there. What?
What's the magic number?
I don't know what the magic number is. I know that it's in the ImportLib library somewhere. I think it might be in util. No, okay. Actually, I don't. It's somewhere in ImportLib. I'm not going to go hunt for that right now. It is some kind of hard-coded thing in Python. It does change between Python versions typically. Like if they change the it's good because sometimes the bytecode format changes from like Python 3.3 to 3.4, and in order to detect that has upgraded, they have a different magic number on it.
It's magic underscore number uppercase.
Is it in util?
Yep.
Very good. Okay, so it's just some byte string of stuff. There'll be a quiz later on that. Remember that. Isn't there like a trivia thing going on tomorrow night or something? Like, okay, that would be a really good geeky like trivia question for somebody. What is the magic? Okay, so that's what PYC files are. There's also this module cache that enters the picture. Essentially, with the import statement, what that does is if you import a module, it just immediately goes to the cache and just says, "Hey, do I know about that?" And if so, it just returns it back. That actually relates to one thing that I get asked about sometimes in training classes. Every now and then you'll see a Python function where somebody will do an import inside the function. It's not considered sort of great style or something, but you've probably seen that where somebody will do an import inside the code, and then the question that comes up is, does Python like reload the module every single time it calls the function? Like, you know, it's an honest question to ask, right? I mean, it's like you have an import and a function. Does every single time you do the function, does it go out and like reload the code? That operation is basically nothing, because what happens is import just immediately goes to the cache and it says, "Do I know about math? Yeah, I loaded it. Done." So it adds like a dictionary lookup essentially. So. Yeah, it'd be like if you kind of a lazy, like it loads on demand and so forth. Yeah, kind of. I use it occasionally, but I think it is kind of frowned upon. I mean, it kind of like most people like to have the imports at the top of the file just so that they can see what the dependencies are, as opposed to having an import kind of buried in the control flow of your program somewhere. So so you just pull it out of the cache. The cache is populated prior to the execution of the module. This is going to be important in a second, but what happens is Python will make the module object, which is empty, and then just drops it in the cache. And then what it does is it will run it. Now, one odd thing is that after it runs it, it actually goes back to the cache and returns the copy that it found there, or it returns whatever was found in the cache. It turns out that might look a little weird, like, okay, I just made the module and I put it in the cache. Why am I going back to the cache? It has to do that to do these things like this package upgrade hack I mentioned earlier, like the XML package looks for like an optional better XML package and then it like upgrades itself. That wouldn't work if it didn't do that. So there's some kind of hacking that goes on there. There's also some things with that cache that come up for some that deal with some edge cases of import. So here's one edge case. Cycles. Probably everybody's done this at one point. Like you have a module that imports another, and then it goes back and imports the original. Like let's say you have an import cycle like that. That will not crash Python. I mean, you won't get into like an infinite loop or anything. I mean, the reason that you won't is that when it comes back to the original module, it's already in the cache, and Python's just like, I already have it. It's like that. So that cache is actually preventing that from going in kind of like an infinite loop. But you do end up with some really weird scenarios that can come up. One of the things that happens is the definition import order starts to matter a lot. Like let's say you have this file foo that imports bar, and then bar imports foo, and then let's say bar tries to use something in foo. If you kind of chase the whole control flow of that, you'll often find that like this module foo that got imported over here is not completely loaded. It ends up being kind of like a partially executed module or something that's set up. And really kind of the only way to fix that would be to swap definition orders and imports and something like you might have to take like the definition of this function and the import, like swap their position in the file. And then you're going to have to answer to the PEP8 gods or something, where it's like, why are you putting the import at the end of your file or something? And I don't know if you get fired in your code review or something for not following the style guide there. So yes, cycles are kind of an interesting case. Another really interesting case. Actually, sort of a more interesting variant of that is what happens if you have cycles and sub packages. Don't do this, by the way, but it's like if you had two components of a package that do a cycle. Python actually hates that. It'll just crash outright, sort of saying, I don't know what you're doing. The thing that happens there is it ends up in this really bizarre cycle where, let's say you said import spam.foo. It comes up here, it would go into that, it would go into foo, and then it would say, oh, actually I want to import bar. So it would kind of cycle into this bar function. Okay, it would say bar.py. And then if it tried to import foo, it would actually find that it has not actually been set up in the package yet. It turns out that these top-level package variables only get created after the completion of the whole import. So the whole thing ends up, you end up getting your head like tied in a knot, basically, and the whole thing sort of goes haywire. You can actually kind of hack around that by pulling things out of the module cache. I mean, I've actually seen code that has to do this where essentially everything is in the module cache at the time the import is taking place. So if you actually need to get to something in the process of import, I mean, even if it's in like some crazy cycle or something like that, you can usually yank it out of the cache. Again, I would try to avoid that. Like if you had to explain this code to your coworker or something, like why am I trying an import and then then if it fails, pulling it out of the import cache or something, it's like, I don't know. It's like a sign that it's time to stop digging. Probably, you know, that's the on that. But it does come up, and then there's like this other really evil thing that comes up with the putting import statements inside function calls. This is probably not something you want to think about, but let's say you have a function that has an import statement inside, like the lazy load thing. Somebody mentioned, yeah, you could lazily load your module. What happens if that takes place in like independent execution threads? Like you have multiple threads in your program, and then they all decide to hit that function at the same time. You actually end up with the possibility, like some really weird corner cases in import. Like one possibility is that you could have two threads that try to import, and they both realize that it's not in the import cache, and then they both independently execute the import. Python does not do this, by the way. We'll talk about that, but like that would be one possibility. Is that it basically executes the same module twice in parallel in two threads, and okay, head explodes with that. The other possibility is that one of the threads would realize that, oh yeah, the module actually is there. It is in the cache. Go ahead and use it, not realizing that it actually hasn't finished executing. So then you end up with like a thread trying to work with like an empty module or something. So it turns out that Python actually has to do locking on the import statement to deal with this. So it turns out that there's yet another sort of global lock dealing with import to synchronize this. It's not the same as the global interpreter lock. It's sort of a, I don't know what it is. So it's sort of a global import lock that's doing that. Turns out that that's actually even more sort of subtle. Python will basically allow like multiple threads to do imports at the same time if they're on different modules, essentially. And then there's, on top of that, it's doing things like deadlock detection and all sorts of other things. Essentially, that's only going to come up if you're doing like multiple threads with like circular imports between submodules or something. I was like, don't do that. I mean, don't do that. But there is like these corner cases in import that come up. The other thing about import that I would mention is that the import statement actually is sort of directly handled in Python's bytecode. It's actually like a statement in the bytecode. One thing about how that works is it actually tries to invoke this _import function. So it's actually hardwired to do this. So the import instruction actually goes out and tries to execute this import built-in function. So built-in, this import, this is actually something that you can use yourself. Like if you were to say import socket or something, you'll do the import on the socket module. And you can, okay, returns that. Okay, so this is something that's actually doing the import for you. Turns out that that's actually a user definable feature. I'm not sure I would recommend it, but if you want like a lot of excitement in your life, one of the things that you can do is you could import like built-ins, and you could say, okay, I'm going to define my own version of import. Like that. And then I'm just gonna, I'll just say, okay, I'm importing name. And then I'm just going to return the built-in one. Okay, so what I'm doing here is essentially just putting kind of a wrapper around the import statement. Again, don't do this. Okay, so doing that. If you do that, you'll actually hook the the import statement. Like you'll see it. You'll see every single import that it tries to do. But essentially every single import goes through that. There's all sorts of evil, insane things that might be possible with that. Yeah, so you see lots and lots of imports going on. Some of them without names. It's kind of interesting. But that's what's actually happening underneath the covers. I mean, essentially, import executes an instruction. It goes to that import function. That import function, just to emphasize, is not significantly different than that thing that we just did, the simple one. I mean, essentially, it finds the code, compiles it, executes it, returns a module object. So you can mess around with that. One thing that I'll just note, there's actually a kind of a recommended alternative to calling that. I mean, if you ever feel like you need to import a module by name like that, it's actually recommended that you use ImportLib instead. So if you ever do need to like programmatically load a module, it's much better to say ImportLib. I think it's just import module socket or something. So that's sort of a much better way to do that, as opposed to doing the low-level import. It turns out that this higher level one has some convenience features on it, such as being able to do relative imports, which the other one does not know how to do. So you can do that, and again you can patch that, and do kind of crazy things with it. I would actually encourage you to try that, just to kind of play with it at some point. All right, so little interlude again. Modules, basically just objects. It's just a dictionary. Importing is just an exec statement, just kind of hiding behind the scenes. And there are some tricky corner cases. Mostly you don't have to worry about it, but there are some crazy things that are possible there. Let me just pause for a second, see if there's questions about that. Everyone good with that? Yeah.
Is it possible to have a positive list inside the import? And then, for example, you can give someone that code and not allowing them to import regular expressions in their code.
Okay, so say that. I'm not sure I caught totally the first part of that. So yeah.
Is it possible to check if the person is trying to import RE and then returning none instead of RE module?
Okay, so the question is could you check to see whether somebody's returning, importing RE and then return none from import? Actually, I have this feeling. Yeah, that's a good question. I think if you were to return none from import, it would actually look like it did the import, but the module object would be none. And then they would try to use it, and then all hell would break loose. You'd get none object has no attribute, find all or something. So. Yeah, you can do some crazy stuff with this. Now, actually, on the subject of crazy stuff, this is where things get kind of cool. You can subclass Python's module type. You're okay, why would I do that? It turns out that you can take a Python module and create your own kind of custom version of it to do different things. And here's an example of that. So earlier we had this question, or we had this code where we were taking submodules and importing them up into a init. This is the code that we had earlier. We're taking the pieces and stitching it all together. And then we talked about the performance of this. Let's say you had a huge package and you have all these things heading towards a init. Is this thing going to take 30 seconds to load, to import? Could you do something? So here's an idea. Could you make the components only load when they're needed? Okay, so actually I have this in some code here. Okay, so let me do an example of that. I think this is in the lazy assembly module. Okay, lazy assembly. Okay, so what I have here is I have a package spam, and there's basically a file bar.py that looks exactly the same as the other one, by the way. It's just it has the all variable, has bar and so forth. Okay, so we have the two files, the same thing as before. Keep in mind they both have print statements in there to say when it's loaded. And so here's the question: could you could you do something like this, where you'd say import spam? It did not load the submodule. Okay, there were no print statements going on, but it would just let you use the packet, like the submodules, as if they were there already. So you see, like when I created that foo object, it said, "Oh, actually, I'm going to import that. I'm going to load it." Same thing with like spam.bar. It's like, could you do a hack like that? Well, since you're seeing it, the obvious answer is yes. You could do a hack like that. So, and you can say, okay, well, how would you do that? Well, I'm just going to kind of briefly show the code. I'm not going to step through it because like everybody would pass out from sleep here. But here's the idea. Essentially, what you could do in the init file is actually just make a like a little mapping that just sort of indicates where things are located. This is kind of the trick. So I have a little mapping here that just sort of indicates like what submodules contain which symbols. Okay, so here I'm saying, okay, .foo contains foo and .bar contains bar. And then I'm going to flip this whole thing around into a Python dictionary that just sort of says, okay, these are where the symbols live. Don't worry about the code so much. But in the init file, I'm basically making a mapping saying, okay, foo is in .foo, bar is in .bar. And then what I'm going to do is I'm going to hack the module type by re-implementing its getAttr method. Okay, keep in mind getAttr is what the dot looks like. If you say .x, it goes to getAttr. So what I've got here is I've got this like getAttr thing where it's like, okay, you give me a name, and I'm going to go to check to see whether I know anything about it. Like, do I know anything about that? Is that, do I know where that is? And if I do, I will dynamically load the submodule. Okay, so what I'm doing here, you give me a name, I'm going to dynamically load it, and then I'm going to rip the value out and pass it back to you. And then what you can do is actually use this. This is so bad. Okay, so what you can do is then take this like custom module type, and then replace yourself with that. So what's happening at the end here is I essentially take this like special module and I drop it into the module cache at the end of import, at the end of that init file, and then all of a sudden this like lazy module thing is taking place or taking over. It's sort of insane, actually. I mean, if you were to look at what this spam thing is, it comes back and says it's well, it says it's a module, but if I look at the type of it, it comes back and says, yeah, I'm actually like an on-demand module type. It's like some special weird thing going on. Okay, so it's like, huh, all right, that's kind of interesting that you can do that. This is not my idea, by the way. This is the idea. I don't even know whether it's Armin's idea, but I encountered this by looking at Workcity. So if you've ever seen that. That's what's being used in that package. Essentially, there's like a huge mapping of objects that are in submodules that get set up, and then if you access it, they automatically get loaded on demand. Is anybody horrified by that or intrigued by that? Yeah.
Well, to me, it recalls the classic thing of don't optimize until you need to. I mean, you wouldn't want to prepare this big framework before you really had demonstrated there's a problem.
Yeah, the question. Yeah, the comment is that don't optimize this first. Yeah, that's good. I would not start with this approach. I mean, this is maybe something for later. Okay, so that's it's like okay, that's kind of interesting. Now some other madness on that. Actually, before we get into some more madness, let me just any other questions on? Everybody's going to go out subclass module now. That's good. Now some other things that enter the picture. I want to talk about module reloading for a second. Module reloading. Okay, module reloaded. As previously noted, not to read the slide, zombies get spawned in your program if you reload modules. I don't know whether everybody's completely up on why, but let me kind of do a scenario on that. So, okay, reloading, bad idea. Actually, let me just make a directory reload and talk about this for a second. Okay, so let's say you have a file spam.py and you have some function foo in there. Foo, very exciting function there. Foo. Now here's the problem with reloading. annoyed that it keeps resizing my window there. So let's say you're in Python. There are different ways of doing import. Like somebody might say from spam import foo, like that. Okay, there's foo, and they also might say import spam and call things like that. You essentially have two different routes to using the functionality in a module. It turns out that the reload function does not play well with one of those forms. It turns out if you go and if you change like the code, maybe you say, okay, this is the awesome foo that I'm going to have there, and you decide that you want to reload a module. Okay, so let's say you come in here and you say, okay, import lib reload spam. What's going to happen is you're going to find that the reloaded module comes up and says I'm awesome foo, but the foo that you did earlier is still on the old one. Okay, so what can end up happening with reloading is you can end up with like multiple versions of code kind of sitting at the same time in your program, and this is usually not the kind of thing that you want. Certainly not in like production or anything like that. I mean, you can get that. What is happening under the covers, by the way, is that reload is actually kind of stupid. Actually, what it does is reload essentially will take like the original location of the file. Essentially, it'll take the source code, and it will actually just exec it in the existing module dictionary, without even clearing it or anything. I mean, it actually takes like the existing module and just says, okay, just re-execute it. It doesn't even bother cleaning it up or anything. I mean, it's like if there was like existing stuff in there, I mean, it's like, yeah, all right, just re-execute it. So there's a lot of things that can go wrong with that. I mean, one is this. There are even more insane things that can go wrong with it, like what happens if you try to reload a package. So like let's say you had a package, and then you had imports in the package. You get these questions. Does a reload those? And the answer is no, actually, because these secondary imports are basically in the cache. It's like, oh, so if you do a reload on a package, Python will reload the init file, but nothing else. I don't know whether that's what most people want. Probably not, but there's that. There are other crazy things that happen once you start playing around with instances. Like here's sort of a scenario. You can let's say you had a file with a class. You created an instance, and then you decided to change the class implementation and then reload the module. You get all these questions of like, well, what happens with the instance? Does it persist? I mean, does it use the new class? What ends up happening now is you end up with instances, like the original ones still use the original class, and the new ones use the new class. So now you have this code with like instances of two different types like floating around in the code, and heads are exploding, and all sorts of all sorts of bad things are going on. Everyone still with me on that? It turns out that, okay, so what's happening there is that the instances are basically keeping their original class and so forth. So a lot of things that can go wrong with reload, having multiple implementations of code kind of coexisting in the same Python interpreter, that sort of thing. There are some things that you could potentially do to fix this. One simple thing that you could do is actually just detect if you're reloaded. Because reload doesn't actually clear the cache or clear the dictionary, one of the things that you could do is you could just put a check in here. You could say, well, if foo is in globals, like, does it already exist? You could just raise a runtime error. Like, this would be the kind of thing that you would do if you just didn't want people to reload. Like, it's a problem. You don't want users to be able to do it. If you did that and then somebody tried to reload it, it would just come up and say, well, okay, screwed up. But you get it detected that and sort of said, well, you can't reload. Okay, so you could certainly do that. There are even more evil things that you could do. Here's sort of an evil thing. Actually, let me. Yeah, okay, I'm going to do something quite evil here. Okay, so let actually before I do that, I'm going to do the from spam import foo thing again. Okay, so there's basically that. So one thing that you could try, and I'm definitely not going to advise that you do this, but you'll see why in a second. You could say, instead of raising a runtime error, maybe I'm going to keep the maybe I'll keep the original implementation of foo. There's probably a better way to do this, but I'm going to keep the original version like that. Maybe I'll set it to none, and then what I'll do down here is I'll say, well, if you're changing the code, you're going to be horrified by this, by the way. So if there's an original version of foo going around, what I'll do is I'll just set its code to the new one. Like, okay, I'm going to burn in hell for that. So what I'm doing is I'm taking like the code on the new function and dropping it onto the old function. It's like, oh God, okay, what's happening here? So now what happens if you reload spam? It will reload, and then sort of spam has the more awesome foo, and then like foo basically magically updated itself behind the scenes because I like swapped out the code object. It's like, don't do that. There actually are some other possibilities. I'm not going to maybe go through this, but you could have classes that basically automatically update their instances to use the new class definition. A lot of stimulating. I would say no on all that. I mean, it's like there's certain directions that you could go with that, but probably not a great idea. So this reloading stuff, if you're ever kind of thinking about that, really kind of the only sane way to do it is just a restart. Either kill Python or restart it or have some kind of monitor or something like that. I mean, yeah.
This is why they removed it from built-in namespace when they went to Python 3.
Yeah, this is why they removed it from. Yeah, as far as I understand it, nobody could ever get reload to work. In Python 2, it's like reload. It's like there's so many corner cases of weird stuff that can break with that it was just easier to just take it out of the namespace. So like in Python 3, there is no reload function as just a built-in. They do provide it as a library function if you want to inflict injury on yourself or something. But it's sort of insane. I'm sort of thinking about like all the corner cases of this that could just go wrong, and I just don't. I mean, I think you would end up with code that was so convoluted, and yet still wouldn't work in all of the corners of it that it would just be madness, basically. So don't do that. All right, let me see if there's other questions about it. Yeah, don't reload modules. Okay. Now some other interesting stuff. I mean, now we're getting into what is this, like bodies being sliced by knives or something like that? Okay, so I want to go back to the. Okay, so first of all, a little bit of warning. The thing that we're going to talk about has actually been sort of actively changing a bit in Python. The change started in 3.4 and it continues in 3.5. I think the change is actually kind of cool. We'll get to that reasons why in a second, but just a little warning on what's going to happen here. Most people, when they think about import, think of the sys path. Okay, you have this path. There's this gigantically complex process that sets that up, and so forth. It turns out that the sys path is not really what is controlling the import statement, at least not directly. There is a second part of the system, something known as the meta path, that is actually controlling what is going on, and you're like, okay, what is that about? Okay, so if you import sys, you'll find this meta path variable. This exists in Python 2.7, by the way. So this is not a new, like a totally new feature. It's just not as well developed in Python 2.7 as it is in Python 3. So what you find in metapath is you find a bunch of importer objects. Okay, so you find a bunch of importers there, and what happens is if you type a statement like you say import socket or something like that, that name socket is actually presented to each thing on that meta path and it's sort of queried. It's sort of saying, do you know about this module socket? So what will happen is it will go to the first one, and it will. We could actually do this. We can say, okay, metapath 0 is this built-in importer, and it executes a module, a method on that. I believe it's called find spec or something, socket, and it says, do you know about that? Nothing comes back, so it didn't know about it. And then what it will do is go to the next one, and it will say, well, do you know about that? Okay, that one didn't know about it either. And then it goes. It essentially just walks that list, sort of saying, okay, who knows about this module? Okay, so it's going to walk. It's going to walk this list of these importers, sort of saying, okay, who is responsible for this module? That is essentially what is happening there. It's like Python is trying to establish like what thing is responsible for the module that's being imported. And the importers are actually handling different kinds of things. So this one at the end, this pathfinder, that is actually the thing that does sys.path. So there's one of these knows how to do sys.path. The first one, this import built-in importer, is handling things like Python's built-in modules that are like compiled into that. There are actually not many of those, but one example of that would be the like the sys module. Like if I said find sys, it would come back saying, yeah, okay, I know about that because that's a built-in module. Okay, so when you do the import statement, what happens is Python goes to this list and it simply tries to find a module spec. Okay, so it's essentially going through these things, sort of saying find a spec. Now, one little word of warning. This is something that is actually new in Python 3.4. This whole idea of a spec kind of thing. What happens in Python 2.7? I think we can do that. Okay, so let's say you're in Python 2.7. This metapath thing actually does exist, but it turns out to be empty. Because what happens is the whole thing is implemented in C under the covers. So in Python 2.7, this exists. You can actually put your own stuff on there that we'll talk about in a second. But in Python 2.7, it's kind of buried with combination of C code and Python code. So it's something that's been evolving a little bit. We'll come back to that. But Python basically queries this thing, sort of saying, okay, give me a module spec. Turns out that you can do this on your own in the standard library. So if you want to do this thing that I just did, one of the things that you can do is there's this ImportLib.util module, and you can import find spec. What this will do is if you just give it the name of a module, it will tell you where it'll return one of these like spec objects back. We're gonna say what that is in a second, but it's sort of telling you like where is this thing coming from. All right, everybody still with me on that a little bit? We're gonna go down the rabbit hole in a second here with this. Okay, so you have this find spec thing. Now, what these specs are is they essentially have information about where the module is located. It is not the module, just to be clear about that. It's more of think of it as like metadata about the module. So the spec is basically describing the module. You'll see if you try these things, like if you say find spec socket, it says, okay, well the name is socket, and oh, okay, I'm going to load it using this source file loader thing. Don't worry about that. It'll tell you the origin of like where the file is coming from. So it's saying, oh yeah, it's socket.py. That's where I'm going to find it. So it tells you about basically information about that, and so these specs. I mean, they have things like kind of the name of the module, like is it in an enclosing package of some kind? Like what's the parent? It will have the path settings. Actually we can do that. Like if I were to say s is equal to find spec, XML etree or something like that. What's going to happen is it will tell me things like, well, there's the enclosing package. There's the there's the search locations for submodules. It's telling me a lot of information about that. Sort of describing what that is. That sort of thing. It turns out that these specs, and this is actually something, keep in mind, this is really new in Python, but I'm actually kind well, I need to get. I'm kind of excited about this feature, although I need to get out more. It's kind of here's an interesting programming mistake that again I got from like an Armin blog post. So let me talk about what's happening here. Okay, so let's say you have a file that provisionally tries to import something. Like it says, I'm going to import foo, but if it fails for any reason at all, I'm going to a backup. Like if I don't have foo, I'm going to import simple foo as foo. Okay, so what this is it's like an optional module. It's like, okay, I'm going to try to import that, but if it doesn't work, I'm going to fall back to this other thing that I have. Now, let's say you had some code like that, and you actually had a file foo.py that was defined, but it had a bad import statement in it. User mistake, like screwed up the name of a module or something like that. So the question is, what is going to happen on that? Well, what's going to happen is the import statement is going to fail, not because foo doesn't exist, but because bar doesn't exist. And then it's going to fall back to this simple thing. And the thing that's going to happen here is there's going to be tremendous cursing on the part of the programmer, because so if they type import spam.foo, it's going to work without an error, but the resulting module is always going to be simple foo. And the user might look at their system and saying, like, this is where they're going to start cursing, is they're going to look on the file system and they're going to say, what the hell, I have py.foo in my directory. Why is it importing simple foo? And then there's going to be like tremendous cursing going on again. You know, it's like Python is busted and so forth. Here's the thing that's cool about these module specs. You can actually use them just to tell whether a module exists without importing it. Keep in mind, this is something that is brand new. You can't do this in Python 2.7 easily, and not even, you can do it in Python 3.4, but it's like a brand new thing. You can essentially say, actually, go just see if you can find the spec for foo. And if you can, then import it. Essentially, the existence of the spec means that that file exists, and Python can potentially import it. Okay, so it's almost like this. Like there's this principle, like look before you leap with error handling. I mean, essentially what that is it's like a look for before you leap for imports. You can say, do I have this, before you actually import it. And if you do that, you'll actually get much better error messages. Like if somebody said import spam, it will come up and it will say, okay, I'm importing foo. You screwed up. You're trying to import bar. It's like it's your error. It basically you're getting a much better error message. It just sort of directly points at the user, saying you are screwing it up. I'm not doing this I'm not getting tangled up in this like weird provisional import machinery. So I mean, admittedly that's a little bit in the weeds, but I think it's kind of cool because you couldn't do, like, I don't know how to do that in Python 2.7 very easily. So yeah. Yeah, question, could you decorate import? Probably not. Nah, I mean, you might be able to do it with like a with statement. Maybe a context manager or something like that, but yeah, I'd have to think about that. What the?
Rip out the existing import, check the error message, and then return your import error, the one you expect, and then put the import back in place.
Yeah, maybe. Yeah, I think Arm. You should look at this blog post by Armin. I mean, I think he has. I'm a little bit fried this late, but I think he does something with like stack frame hacking or something. Like if you want to fix this, what you can do is look at Python stack frame to see where the import was taking place, and then either generate an error or not, depending on like what it is. I think the spec thing is kind of cool. I mean, it's just like, okay, we'll just do that. So there's basically uses of these specs outside of the import statement. The other thing that's kind of cool about these specs is you can actually do things with the module without importing it as well. Like like here I did this this, like if I were to say s is equal to find spec on the socket module, one of the things that you could do with that is pull the source code out. I think it's just like load source or something. Yeah, I might have typed it wrong. Oh, dir s. What did I do in the slides? I'm already confused. Oh, the loader object. Okay, so there's this loader object. I'm missing one level there. Okay, so there's this loader object that gets attached to these specs. You can actually use that to do things like get the source code. I mean, you can say, oh yeah, just give me the source. You might need to give it the name, and then like all of a sudden the source code comes back. That did not load the socket module. I mean, it's just like it's using some part of the loading machinery to get at that. So you can do that. The other thing that you can do is actually create the module or bring it into existence. So one of the things that you could do, and I'll kind of demo this, is let's say you had this spec for the socket module. You can essentially create a module type. So you could say, okay, I'm going to make a module type called socket, which is, okay, there's the socket module. Right now, it doesn't have anything in it. It's just like an empty dictionary. And then what you can do with the spec is you can say, okay, I'm going to go to this loader that knows how to bring the thing into existence, and I can say, why don't you just execute the module in this thing that I already created. I can say, what you're doing there is you're just saying, okay, execute the module in that thing that I just made. And then what will happen is you'll find that the module has been populated at that point. So there's all sorts of kind of weird things going on here where you can basically find modules on the system, and then you can do things like create module objects on your own, and then ask Python to create to execute the code in this newly created thing that you just made. Again, keep in mind that this is not something that is possible on anything below Python 3.4, and it's almost like they've taken the module system and opened up a lot of the pieces of it, where you can say, okay, go find it, execute it, pull the source code, and so forth. You might look at that and say, well, what kind of crazy thing could you do with that? I mean, what's actually happening is you're kind of decoupling a lot of you're decoupling the pieces. So here's kind of an interesting idea. This is actually getting back to this performance thing. Like maybe you don't want to import the whole universe or something like that. So what if you had some ability to do what I would call a lazy module import? Like you could say, okay, I'm gonna do an import of the socket module lazily, where it will actually create the module object, but it will be empty when you create it. Let's do this. So I actually have the code for this. So there's lazy import. So let's say I had a utility function here called lazy import. You could just say socket is equal to lazy import socket. And you would look at it and it would say, okay, socket object. And it would totally identify itself. It'd say, okay, socket object from socket.py. If you looked at it, it's empty. There's nothing there. Except that everything is there. It's there. Yeah, socket AFI net. The whole module is there. And it's like, wait a minute, what just happened there? Do a dir on it. Oh, it's there. It's like essentially what you have is you have a module that it didn't actually. It's like I imported it, but nothing happened. But then when I tried to access it, all of a sudden it came into existence, like all on its own magically behind the scenes, and you're like, okay, that's crazy. What is happening? Like so you that is the kind of thing that you might be able to do with this new machinery, is having things decoupled. The way that is implemented, by the way, is more get-adder hacking. It's like big surprise there. I mean, what you could do is you could say, okay, I'm going to make a custom module type. Don't worry about the details so much, but you have a custom module type where the get-adder essentially executes the module on first access. It's kind of like, okay, when somebody accesses something, I'm going to execute the module then, and then I'll kind of upgrade a few things behind the scenes, and so you do that. I mean, essentially, and then the lazy import function all it's going to do is it's just going to check the cache. It'll say, well, if I already know about it, I'm done. Like, okay, done. Otherwise, what I'm going to do is just find the spec, and then I'm going to create one of these like lazy importer things just with the spec. It's not doing the full import basically. It's only doing part of the import, and then it will do it. It'll do the rest of it later. Whether this is a sane idea or not, I don't know. Except it's not my idea either. This is something that has gone on in Python 2. Philip Eby has an implementation of this in the. I'm trying to think what. Oh, the importing library has that. It's sort of a kind of a crazy thing that he's doing. I think the code for that is slightly. What it does is it creates like an empty module, and then what the getAttr method does is it triggers reload on itself, and then Python like brings it into existence. So it's not a new idea, but in Python 3 it's actually been kind of formalized, or it's kind of coming together into something different here. So question up here.
So if you do this lazy load and you try to set something on whatever it is you get back, does the thing that you set get clobbered when the lazy load happens?
Okay, the question is if you set something before it gets. So the question is if you lazy load a module and then you set something in the module. Does the thing that you set exist after it executes? I think the answer for that is probably yes, but we better test it though. So let's say you said socket is lazy import socket. Okay, so there's nothing there, and then let's say you came in and said socket spam is 42, and then you said socket if_inet. So it's loaded at that point. And then the thing that you set is still there, but now you have all the socket stuff. We're increasing job security for ourselves by doing that there. So yeah, it's kind of madness on that, but it's this is something I think this is really kind of cool that they're opening up kind of the import machinery like this in Python 3 because you get all these like interesting new possibilities. So
I assume if you set a name that was already in the module, it would get squashed.
oh, if you set a name that was already there and then it and then
Get it back.
So like you're trying to monkey patch?
Yeah, I'm just trying to.
oh yeah, that's true. Yeah, actually, so if you had the if you did a socket equals lazy import socket, and then you said socket AFINet is equal to like 2 or something,
And then try to get AFINet again.
and then if you tried that, yes, it's probably it's still not loaded because of getAttr doesn't.
Yeah.
It only fires when the first unknown thing.
You set AFINet to 42, and then try to get something else.
Yeah, so if you set it to 42, and then you said AF like sockstream or something, it should squash it. Yeah, so it flips it back. What is our official end time, by the way? It's 4:40, right?
Yeah.
Okay, I want to make sure that I don't have to end in like 2 minutes here. Okay, so we're doing okay. But so yeah, this lazy loader thing. I don't know. I mean, it's kind of. I mean, you could like if you're concerned about like startup time. I mean, you could imagine a scenario where it's like, okay, I'm just going to lazy load the whole universe to have it there, and then like when people access it, then I would use it. It's kind of crazy, but it's possible. Possible to hook into that. The other direction that you can go with this is you can also plug into the import statement if you know what you're doing as well. So one of the things we noted is that Python basically tries to find a spec for a module. Like it goes to that meta path thing and it tries to find a spec. One of the things that you could do is plug into that. Okay, so import sys. You could make like your own class, for instance. I'm just going to make a class called watcher here that defines a class method called findSpec. I think there's I'm not exactly sure of the other args, so I'm going to punt just to be safe here. Okay, so you can put a find spec on there, and then let's just see what happens. Okay, finding name. It turns out that if you were to take that and you were just to insert it onto that meta path like that, you would actually start seeing that fire if you if you gave it like unknown module names. Like if I say import blah, you would see it come up. Oh, finding blah. I don't know anything about it. I didn't return anything, so it's not doing anything. But you can essentially hook things onto that meta path list and watch the import statement. The position of where you put things on that path will tell you how much information you get. Like if you were to put this watcher thing on the first position, essentially, you would actually see it checking for everything, kind of at the beginning. Yeah, I'm not. Let's just try a few things. Okay, so you actually see that see that thing fire. And so one possibility is that you can actually hook into the import machinery and do just completely different, insane kinds of things with that. I thought of some like different examples that we could try. One thing that don't do this. This is a bad idea. I thought, wouldn't it be cool if you could just auto-install missing imports through pip on first access? So so if you type like import requests or something like that, if it didn't work, wouldn't it be cool like if you could just like have it magically load itself, in the back? Keep in mind, really bad idea on this. So here's an example of that. Let's try that. So I have this thing called auto install. I'm gonna do this in a virtual environment, just because I don't trust what I'm doing here. Okay, so what we're gonna do is make we're gonna have a virtual environment PyCon here. There's Python and Python 3 in there. If you're not using requests for scraping the web, by the way, you should be probably using that. So it's awesome package. So you do an import, doesn't find it. So I have this thing, this auto install thing that you can import. What it does is it hooks that meta path thing to basically put like an auto installer on the end of the path. Okay, so you see this thing at the end where it's like, okay, auto install, and what this is going to do is try to pip install what you just. So if you type like an import like request, it's going to try to go get that. Now, just to make sure that this works, I need to verify that I'm actually on the internet here. So I don't. It's not that I don't trust the Python, the conference site. Okay, it looks like I'm there. Okay, so what I'm going to do is try to do import requests, and like you just watch the magic there. Okay, so it's basically like pip installing that on the background. Really bad idea.
Well, these all fail.
Well, some of them, I don't know why they might be optional. Well, they don't have a pip. Maybe there's no entry in like the Python package index for. I don't know what NDG is.
WinReg is Windows Registry.
I know what WinReg is. I think it might be. Is it renamed in Python 3? Yeah. Anyway, so it's trying some things. Basically installs that, and then it's just available. Again, really bad idea. It's so it's like okay. So there's the basically it found that and then brought it in. I don't know what would happen if you tried to do this with something more ambitious, like import NumPy or something. We'll let that go for a minute. But what's going on here? It's the stupidest idea here. So this auto install thing, it actually keeps a set of everything that's loaded. It's attempted to load already, just so it doesn't keep retrying stuff. And then all it does is it executes pip as a sub-process. Again, this is world's dumbest idea. So it tries to execute it as a sub-process, and then it just tries to find the spec again. So if it succeeds, it should find the spec and then just return it back. Really stupid idea. I mean, don't do that. But it is kind of an example of like some insane thing that you could do with an import. An import hook is like auto loading modules. Actually, I wonder how that sweet. Okay. Yes. Okay. Good. Okay. So yeah. All right. Awesome. Okay. Yeah, I'm going to go pandas too. Okay, while that's going. Okay, so there's that idea. Some other possibilities. Maybe you want to import modules out of some completely non-traditional place, like a Redis database. I don't know that people mess around with Redis or not, but I'm hoping that I actually installed it on my machine here. So let me. Okay. I'm not going to fiddle around with it if I didn't for some reason, but maybe I don't have it. My bad there. Okay, so anyway, let's say you had Redis or something like that. You could do things like, okay, well, I'm going to drop Py files onto a Redis database. If you haven't used Redis, it's just like a key, well, it has a key value store amongst another like 300 features. Okay, so you could imagine putting like code in a Redis database, and then you just drop like an import hook onto this meta path, and then you just have it like querying that, and you're pulling Python objects out of Redis. Why not? It's like okay, it's web scale or metal or something like that. Okay, so that's there's lots of interesting possibilities there. I'm not gonna. You can look at the code. I mean, figure that out. But let me see if there's questions about that before we take it one step further here. Getting close to the end here. Let's see how that pandas thing is doing. Let's. Yeah, okay. I see it kind of at the top of the window invoking Clang and stuff, so I see. Installing thread. Some of these look like they're old like Python 2 compatibility things. What might be happening here is like a provisional import, sort of like if you've done like code that needs to import on 2 and 3. You might do something like an import, and then if it fails, you go to try like something else. Oh, matplotlib. Oh, awesome. Okay, well that's going to go for a while there. Okay, so some other possibilities. This is not boding well. A person stabbed, and there's like people being eaten by animals in this picture. I think. Okay, so it turns out that the path is not the end of like this meta path thing is not the end of the story either. So if you go back to the path, it turns out that there's yet another thing that is processing that. It turns out that there's this thing known as a path hook, in addition to all of this other stuff. So in the sys module, we'll come back to that. There's this variable path hooks, and what you'll find in there is like a couple of things, and you're like, okay, what is that? Okay, so what is going on here is that if you look at the sys.path variable, there's different kinds of things that can go on there. There's like zip files, there's directories, egg files, and so forth. The purpose of this path hooks is to find something that knows how to deal with a specific path component. So what happens is if you have a file name, like let's say you had a file, spam.zip or something, what Python will do is present that to these path hooks. So what it will do is it will go to the different path hooks and sort of say, okay, well, do you know how to deal with that? And it will respond back with some kind of information. Now, the reason that this is complaining is that file doesn't exist. It essentially, I said spam.zip doesn't exist. If for some reason that file did exist, like let's say, I were to say zip, spam. Like let's say I were to make a zip file, and then I were to try that same thing. Okay, file name is equal to spam.zip. If I were to go to the path hooks, okay, keep in mind there's the hooks. If I were to say sys.pathhook0, do you know about this file name? It would come back and it would say, well, okay, there's a zip importer object for spam.zip. We'll talk about that in a second. If you had it like a different file name, if you just said, well, here's my current directory, and I said, well, do you know about, does path hooks 1 know about that? it would come back saying, yeah, there's a file finder. So what's happening is each component on the sys path gets presented to this path hooks thing. And what's happening is Python is returning some kind of importer object that knows how to work with that. It's sort of saying, okay, I know how to. I know how to work with that thing. So all of the path components kind of get presented to that, and they it sort of tells Python whether it can be handled or not. Now, what is happening with the results of this is they are actually used to locate modules. So, for instance, this thing that came back, this file finder. Let me just save that. That actually has that method like find spec on there, where I can say, well, find the spec for spam, and it will come back sort of saying, well, there it is. So actually what's happening with that sys.path is Python goes through all these entries to get these loaders, essentially, or these importers, and then when it wants to find the module spec, it actually just asks them one after the other. Like, do you know about this? Do you know about this module? And then you sort of get the same machinery that you were messing around with before, kind of coming into play there. So this is and then to make matters worse, it turns out that all of this stuff is cached under the covers. So if you wanted even more in the sys module, there's this thing called the sys path importer cache that will tell you where things are coming from. Maybe I'll print that. Okay, so what's happening here is you essentially see a list of all the entries on the sys path, along with some kind of like object for finding things in that component. Okay, so you can certainly mess around with that and see that. Now the reason that I'm talking about this is you can hook into that as well as a programmer. I mean, essentially, you can write code that plugs into this path hook, and as an example of that, what if you wanted to import Python modules off of a website? For instance, what if you wanted somebody to just be able to append like an HTTP address into the sys path and pull code out of that? So let's do an example here. Okay, so. Everybody's got to be horrified here. Okay, so I think this is webhook. So what I'm going to do here is I'm going to have I have a directory of files. Okay, this is just a directory of files there. I'm just going to run Python's web server on that. Okay, it's awesome that you can do that, by the way. Just one line, run in Python web server there, and then imagine that's maybe some other location like GitHub or something like that. Again, terrible idea. So, but what I'm going to do is basically run. I'm going to have some code where I can import like a special module. I'm going to call it webhook, and what I'm going to do is just on my sys.path, I'm just going to append like a URL. I'll just append like localhost 8000. Okay, so there I have a path entry for that, and actually let's look at it. Okay, so on the path I have a URL, and with this hooking into this path hooks thing, I can actually just start importing modules like import foo and bar, and you can ask, well, where did that come from? Well, it came from there. Like, okay, module foo from like some HTTP address there. If you go to the code where that's, okay, you see it like pulling it off of there. So that's kind of like another like angle on this import customization is to do that, like pulling things like off of like path components or URLs or other things. So a lot of customization is possible. As far as how that is working, again, I'm not gonna go through it in huge detail, but what I actually have is a URL hook that essentially what the critical part is it checks the name to sort of see, does it look like a URL? Is it HTTP or HTTPS? If it is, I do I basically pull the website and use a regular expression to find all .py files on. This is a really bad idea, but I'm sort of making a collection of everything that seems to be linked on that page through a py file, and then I build some like finders to basically look for things. Again, I'm not going to go through all the details, but you see a lot of these things like building specs, like spec objects. You have to have some code to exec a module and so forth. Again, this late in the day, I'm not gonna go through that in detail, but it's more like, okay, that's interesting that you can do that. So bottom line, you can make custom paths. You can hook into all this machinery. I mean, if you think about like all the stuff that's possible and like they've covered in the last hour or so, I mean, it's like customizing module objects, hooking into the import statement, hooking into like the path handling and stuff. I mean, there's like a crazy amount of stuff that's possible if you have too much free time on your hands. Okay, so so we're getting kind of near the end here. I'm sort of seeing like 8 minutes left. So some final comments on all of this. There's a lot of moving parts, like a ton of moving parts. I mean, I'm not even sure I fully have my brain wrapped around all the parts, to be honest, at this point. I mean, it's like a lot of things going on. There's a lot of stuff changing in the Python world with this. I mean, in Python 3.5 is changing a bunch of stuff. One of the things that's happening is they're taking like different pieces of the import system and kind of breaking it out into independent things that you can use all on their own. Like finding modules or partially loading things or testing things. I mean, I actually think that's really interesting from a kind of a development point of view. I mean, it opens up things that I might do in a framework that I would not be able to do otherwise, or I'd have to do some really hacky thing to get the same effect. I think as probably a policy, I'd probably stay away from a lot of this stuff. I mean, at the break, somebody asked me, it's like, should you be doing this stuff? And I think I said no. Did I say no to whoever asked that? Actually, I think I said I'm not sure. Yeah, I think that I'm not sure whether you should be doing things like this. I think as a programmer, I like to know that this is possible in case I have to debug somebody's code. Like if I have to go debug this, I want to know what the whole space of possibilities are. Maybe if I see the summer intern coding something like this, I can put a stop to it before it gets too far out of control or something like that. But it's interesting to kind of know what's going on. Finding documentation on this is also really, really tricky. I've found I'm not aware of sort of a single point of documentation that kind of covers the whole picture. Does anybody else? Do you know of a single point? It's really kind of hard to pin down. The official library documentation is not bad. Like if you just go to Python 3 and you find like the reference documentation, there's a ton of PEPs that cover this kind of stuff. And some of these go way back. I mean, these are like PEPs that are going back like 14 years, 15 years, where they're talking about, we should have import hooks and all these things. And it's been kind of this constant evolution of ideas that's been evolving. So if you're interested in that, that's where you find things. There are some related talks. Brett Cannon gave some talks at PyCon a couple of years ago talking about how the import statement works. They're pretty low level. Actually, he has this like insane flow chart that he starts with, and it's like all these wires and all this stuff. He sort of explores the flow chart. So I was trying not to totally reproduce that here, but you might look at that. Other than that, I'm basically done. I mean, we have some time for questions, but I hope in this tutorial, it's maybe just kind of. And I was describing it to somebody. It's kind of like in the garden where you like lift up a rock. And you see like all sorts of bugs under it. I mean, I do that with the kids a lot, where it's like, let's go. Why don't you go lift up that rock? And you lift it up, and there's like all sorts of crazy stuff crawling around under it. And I sort of feel like this tutorial is maybe that, where it's like, okay, we'll lift up the corner of the import system and see some crazy things going on. Now put it back down and try to forget about it. But I don't know with that. So I'm basically done. I can take some questions and. Thoughts, comments, yeah.
In the beginning you mentioned that knowing some of these things, you change some of the things you do. Can give some examples of as to what changes you made?
Yeah, I would say the biggest impact for me in this talk. So I've been working on a project with a startup over the last couple of years. Is more on the area of just organizing my code, like having a better awareness of like just package structure and like interconnections between the pieces. So like just like knowing how to export symbols. I use a lot of the main program stuff a lot actually, like the -m option for like packaging things up. I thought that was really cool. So I think like personally, it's more just having an awareness as like an application developer of, yeah, these are the things I can do. I'm tending to keep things kind of simple, honestly. It's like just knowing that, you know, the relationships between like packages and namespaces. Yeah, question, Mike in the back.
Lazy import, I think Mercurial is a it's very important that it's very hard startup time. So they have a very sophisticated lazy import.
I haven't. Yeah. So the comments about Mercurial. Do they actually have a lazy import thing? I mean, one of the things that maybe they're responsible partly for the so Python 3.5 I think actually has some kind of lazy import built into it. It's not documented at the moment, but there is like I might be looking in the wrong. Yeah. Okay. So there's like so in Python 3.5 they actually have this lazy loader object. This is not in 3.4. It's a 3.5 thing that actually does that kind of lazy module import that I talked about. I don't know what the origins are of that. I mean, do you think it might be out of Mercurial? I don't know. A lot of this, I mean, this is definitely stuff that people are thinking about. Where it comes from is often not clear. I mean, I'm not even sure whether that lazy loader has any help on it or anything. No, okay, it has a brief description of it. Yeah, loader that creates a module which defers loading until attribute access. So it's kind of the same thing that we kind of hacked, part of the standard library. So somebody's thinking about it. People will start using it in 25 years when Python 3 becomes the more common version of Python there. So yeah.
You gave a bunch of disclaimers about how awful a bunch of these ideas were, and you seem most horrified by the auto-pip installation example.
Yeah.
Is there a particular security or other reason for that level of horror with that one?
Like the auto install on pip. There's a lot of I don't tend to like things just being auto magically installed because I don't know what's going on sometimes. And then also there's problems with it as well because sometimes the name of the module doesn't match the name of the package import. Like, you know, so if you import a module, it might not be named the same thing on PyPy. So it's who knows? It looks like my pandas thing came back though. So you know that actually says quite a bit because this is actually Python 3.5 alpha 3. I mean, we're not even in like a beta version of Python, and it seemed to successfully install matplotlib.
I mean, there's precedence for that kind of thing on like Maven in the Java world, do auto installations on packages and stuff like that. I mean, this is like that kind of an idea.
Yeah, doesn't Go do that with like Go pulling stuff off GitHub and stuff? All right. Well, it installed matplotlib, but it doesn't seem to. Yeah. Okay. I'm not gonna worry about that. But I don't know. Well, anyway, I'm gonna let people go. But yeah, thanks for coming to this. Hopefully, it was. Hopefully, you learned one or two new things.